To develop a multi-room platformer, we're going to start by creating a basic physics simulation that uses classic concepts like acceleration and gravity. Then we'll restrict our player to a certain area using collision blocks derived from a third-party map editor. We'll completely transform our player by adding in sprites and animation, then code the functionality required to move our player from one room over to the next, giving us the ability to create a complete world in which our users can travel and explore. This course was made possible by today's sponsor, Into the AM. Into the AM is a clothing company that makes premium, high-quality apparel, and over the past month, they decided to shimmy out a few t-shirts. Now, I'm not just saying this as a sponsored party, but these are honestly pretty much all I've been wearing over the past month. They fit me near perfectly, and whatever material they're made out of is just way softer than anything else I have in my dresser. So they're currently running a bundle deal for tees, which is 3 for $50. So if you're interested in grabbing some super soft, well-fitting t-shirts, then click the link down below, and on top of this bundle deal, you'll get an additional 10% off. Now let's hop right on into things and start coding. So the first thing we need to do to set up our multi-room game is, well, set up a project. So how do we go about that? Well, the way I like doing it is opening up a Finder window, whatever it might be in Mac or Windows, doesn't really matter, but I like opening up a window, and then finding a directory in which I like to store all my games. For me, that is personally within a web directory. Once I'm within the web directory, I can right-click, hit New Folder, and then determine what do I want this game to be called. Well, the artwork for this game is called Kings and Pigs, so I think that is a perfect name for our game. I'm going to call this Kings-and-Pigs. So our game is going to exist within here, and now what do? Well, I like opening up this folder within my text editor of choice, which for me is Sublime Text. So to open this up over there, I like grabbing this, and then dragging it onto Sublime Text. And what that's going to do is automatically open up my project within Sublime Text. Should work for VS Code as well, but if you're a Windows user, it might not work. All you need to do is open up your text editor, go to Open, and then find out wherever your folder is. Right here for me, it's Kings and Pigs. Hit Open, it's going to open it up. Simple enough, right? So we have this opened. I'll go ahead and full screen this, and that's just going to be step 1. So it's going to open up this blank file for us. I want this to be the place in which we store our canvas, our index.html file. So I'll hit Command S to begin saving this, and I want to save this within our new directory, Kings and Pigs, and I'll save this as index.html. So now we have a place in which we can write out our code. So the code we want to write in here is going to be just a simple canvas element. All of our game code, all of our rendering is going to be rendered out onto this one element right here. This is all we need to get started. So let's save this and then open up index.html in a browser. So to open this up, I'll open up my Finder, double click index.html, and this is what our game looks like, a blank screen. Well, we did add a canvas element, but we can't see it. If we right click, hit inspect element, use the inspector tool right here, and hover over this, you'll see our canvas element does indeed exist. The thing is, it doesn't have anything rendered out on top of it. We haven't changed its color, we haven't changed our background color or anything like that. That is why we don't see it, but we will be changing this shortly. So let's go ahead and make our background black, just to get this really harsh white screen off of us, because we might be coding at night. To get this background color black, all I'm going to do is within index.html, add a style tag, and then select our body element. So I'll select body like so, and declare I want our body's background to be black. So I can save that, refresh, and now our body's background is black. If I inspect this, go over to our code over here, our body element just takes up the whole screen. So when we give this a background of black, well, the whole screen now has background of black. Simple enough. But we do want our canvas to start rendering out code. So how do we use our canvas to begin rendering out artwork? Well, we're going to need some JavaScript. If we want some JavaScript, we can add in some script tags and begin writing in our code. So I want to start by selecting our canvas element and putting it within these script tags, within JavaScript land. To do that, I'll write a const called canvas. This is going to be equal to our document.query selector with a capital S, and what element do I want to select from our options up here? Well, just our canvas element. That's pretty much all I can grab besides body and our HTML tag, which are rendered out automatically in the browser, but we do know we want the canvas element. So I'll specify in here, let's grab our canvas element, and now that I have this canvas element, I can create a new const called C, and set this equal to canvas.getContext to D. So we're taking our canvas element in JavaScript world, and then we're calling a getContext method on top of it, which specifies we want our context to be in the 2D realm. This just means we're going to be using 2D methods to draw on top of this canvas. So with those 2D methods available to us now within this C const, and C just stands for context by the way, this is the one instance in which I'll use a very short variable name because I know I'm going to be using this so much within our actual code. I want to grab C and call fill rect with a capital R. Now this takes 4 arguments. We're basically just drawing a rectangle with this. The first argument is going to be the X position of this rectangle on our canvas over here. We can't see it yet. That's okay, let's start off with an X position of 0. The second argument, indicated by a comma, is going to be our Y position. I want this to start off at a Y position of 0. Our third argument is going to be the width of the rectangle. So from these coordinates, how wide should we draw the rectangle? I want this to be, let's just say, 200 pixels to start. And then our last argument is going to be the height of this rectangle, which I'll also say is 200. So we're basically drawing a square with this. We can save this and refresh, and nothing's going to show because we need to specify what color we should be drawing this out as. So if I want to specify a color, I'll write c.fill style and set that equal to a color of white. With just this, I can save, refresh, and now we're drawing on top of our canvas. So great. What would I do next? Well, I want our canvas to be the right aspect ratio. And I want the aspect ratio to be something along the lines of 16:9 because most computer screens are the aspect ratio, most TVs. It makes a lot of sense to put our game in the aspect ratio as well. So to get a 16:9 aspect ratio, I want to change the width and height of our canvas element, which you can see over there. It's basically the size of that blue rectangle. We want to enlarge this to a 16:9 ratio. To do that, right beneath our C here, I'll select our canvas, and then select this dot width. So we're getting the canvas width. What do we want to set this equal to? Well, I already know the value. It's going to be 1024. And for our height, I'll grab our canvas dot height and set that equal to 576. So what are these values? Well, if we were to compare these together, this is a 16:9 ratio in which we want to use for our game. And we can even test this out because I know that our game is going to be using 64 pixels by 64 pixel tiles. What I can do here is just multiply 64 by 9 for our height, and then multiply 64 for our width by 16, and we're going to get those exact same values we had out there. So this will be equal to 1024, and this will be equal to 576. So that's how we're going to set our canvas width and height. We can save this, refresh. We don't see too much changing, but over here we can see width and height added onto our canvas, and if I scroll over this, now our blue rectangle is taking up that full aspect ratio of 16:9, 1024 by 576. But we do want to fill up our full canvas element with our drawing right here. To do that, instead of using 200 for our canvas width, now we can just use our canvas width property instead by grabbing canvas width and inserting it into fill rect. Same thing for our height. Let's say we want to use our canvas height, fill up the entire thing right there. We'll save, refresh, and I'll exit out of our console right here. And now you can see this is going to be the exact location in which we create our game. Now we're going to begin creating a player very shortly, but what else would I do here for project setup? The very last thing I think I'm going to do is just move all of our script code over to a separate file. That way we can get a little more organized with things. So if I want to put all my script code in a separate file, I'll create a script tag up above, a separate one at least, and then add in a source attribute. The source attribute is going to reference the file in which I want all of our JavaScript code loaded from. So I want it loaded from index.js. But you might notice index.js doesn't actually exist within our project. We need to make sure that we create this file and then put all of our code inside of it. So to create a new file, I'll go up to File, New File, and then I'm going to save this new file as index.js. There's our new file, and all I want to do now is make sure that I grab all of our script code that we just wrote out, cut this on out of the current script tags. This means that I can get rid of these script tags that are on their own now, so I'll delete those. Make sure that I have index.html saved, go back to index.js, and paste in all of that code. So if we reference things correctly and we save both of these files, we can go back over here, refresh, and everything still looks the same. That's exactly what we want. It's just the same look, but now our code is a little more organized because all of our JavaScript code is within its own separate file. So that's all we need to do for project setup. Let's head back to To-Do and check off, well, project setup. Now that we have our project set up, I want to create a player, someone that we can move around on our screen. And to begin creating a player, I want to go over to our canvas, and I just want to create the most simple object possible, and that's pretty much always going to be some sort of square or rectangle. So I'm going to create a rectangle, place them on the screen, and then I want to begin animating our player downwards and have them stop until they hit the bottom, we're going to start adding in some really basic physics and collision detection. So to get started creating this effect, we want to go back to our code, and we're going to reuse the c.fillRect method, but we're going to give it a different fill style. So right beneath this, let's add in c.fillStyle and assign this equal to the color red. So our player is going to be red to start. Now I want to draw out our player. This is easy enough. I want to use c.fillRect and then assign it some coordinates. So let's say I want my player 100 pixels from the left side of the screen, 100 pixels from the top. I want my player to be 100 pixels wide, 100 pixels tall. With just this code, I can save, refresh, and now we have a player on the screen. It's that easy, but now if I want our player to begin animating downwards, well, I need to create what is known as an animation loop. So to create an animation loop, right beneath this code we just wrote, I'll add in a function called animate. The function looks a little something like this. And within this, I'm going to call window.request animation frame. Animation has a capital A, by the way, and frame has a capital F. And this takes one argument, another function. The function I want to call is going to be the very function we just created. So we call animate as our argument right here. And then finally, if we want to actually activate this code, we need to call our animate function down below. Now that code should be running. So how does this actually work right here? How are we creating an animation loop with this? We're calling animate down here, which in return calls all of our code within animate. That is simple enough. What code are we calling within animate? Request animation frame, which takes an animate function. So we're calling this line right here, and once we call it, we're going back to the very beginning, saying we want to call animate again. If we call animate again, well, what do we call? Request animation frame with animate. Therefore, we go back to the beginning, and this is just going to keep running unless we tell it to stop. So if you want to ensure that your animation loop is running, I pretty much always just console log out some text. It can be anything. And as long as you're calling animate, refresh, and then inspect an element and open up your console, you're going to see that Go is just being logged out really quickly. That's how we can tell that our animation loop is running. So what we're going to do with this animation loop is start increasing this Y value for our player over time. And as long as we keep increasing this within our animation loop, it's going to look like as if our player is moving downwards. Pretty much how animation works is we have all these different frames and we start altering small little values within them to create the illusion of movement. So all this code up here is only called once when this file is initially loaded. Now I know I want my player right here, which is defined by these two lines, to be called for every frame of our animation loop. So I'll delete this console log, paste in those two lines, and now for every frame of our animation, we're going to be drawing a red square on top of itself over and over again in this location. It's not going to look much different. We refresh and it looks exactly the same. But once we start adding on to this value right here, we're going to start seeing that movement. So how do we start increasing this value? Well, we need to create a variable, a let. So let's create a let up above, and this is going to be called our y. And by default, it's equal to 100 because that is the value we're using right here. So we can replace our y right here within fillRect with the actual let of y. Save, refresh, looks the same. That's totally fine. I'll exit out of my console. But I do want to begin increasing this value for each frame of animate. So after we go and draw out this rectangle right here, I can grab y and call plus plus to start adding on 1 to this value. So for each frame, we just keep adding 1 onto that initial value. We'll go to 101, we'll go to 102, and we'll just keep drawing unless we tell it to stop. So let's save, refresh, and now you can see we have animation in place. But it looks like a rectangle or square per se is just getting larger and larger rather than actually falling downwards. Why is that? Well, for every frame we call our player code right here, we want to make sure that we are clearing our canvas. By clearing our canvas, we're giving ourselves a new slate to draw new artwork on top of. And if we don't do that, we're going to get this effect over here that kind of looks like a paint trail. So we want to make sure that we're always clearing it. To clear it, we can call c.clear rect, and this just takes the same arguments as fillRect. We can just grab the same arguments up here that we used to initially clear our canvas and plop them within clear rect. We save that, refresh, and now we are clearing our canvas for every frame of our animation. But you'll notice that our white background is gone. When we call clear rect, it's actually getting rid of everything. We're not drawing on a color. So if we want to define a color, well, we can just grab this code up above with these two lines, get rid of the clear rect, and then add in fill style and fill rect. So we're going to make sure that this fill rect right here, this rectangle we're drawing out, has a background of white. We're not actually just clearing everything completely. We're using that white background to make it look like as if we're clearing things. Hope that makes sense. Let's save, refresh, and now things are looking quite great. So we're looking good, but how do we get our player to stop at the bottom of the canvas? You'll see it just keeps on going, even when it hits the bottom. Well, essentially, we need to write out some code that says only increase this y value under a certain condition. What condition is that going to be? Well, let's illustrate this. Well, we know that our player is falling downwards, and we want them to stop at the very bottom. What condition can we write right here to stop our player? Well, let's look at our variables. We have at the bottom of our player. This is going to be the bottom. And how do we get the bottom of our player based on our current variables that are actually within our code? Well, we have a y value, which is the top of our player. This is our y value, but if we were to add onto this our player height, which is this right here, we would get the bottom of our player. So to get the bottom of our player, we need to take y and then add onto that our player height, which right now is equal to 100. Now we know the bottom is one variable we need to track. What other variable might we need to track? Well, simply enough, the bottom of our entire canvas right here. How do we get the bottom of our entire canvas? Well, this is going to be known as our canvas height, because when it comes to canvas elements, our coordinate system starts at the very top left-hand corner. So this would have coordinates of 0, 0. The further we go to the right, the larger our x value is going to be, and the further that we go down, the larger our y coordinate is going to be. So really the two variables we want to focus in on are going to be our canvas height, this down here, and the bottom of our player. And we're going to say once the bottom of our player touches our canvas height, we're no longer going to be adding 1 onto y, and that's going to prevent our player from moving past the bottom of the screen. So let's write this code out. We need to get the bottom of our player. How do we get that? Well, I'm going to write out a let right beneath y. We can call this bottom. We'll set this equal to our current y coordinate, which is the top of the player, plus our player's height, which right now is defined by the fourth argument within fillRect. It's going to be 100. So this will give us the bottom of our player. But if we want to be more specific with our variable naming, we need to create another let. It can even be a const if we don't want this to change. To say our height is going to be equal to 100. And now we know that this fourth argument right here is our height. It makes it a little more descriptive within our code of what we're actually referencing. So we're always adding 1 onto y below. We can write a conditional that says if the bottom of our player is less than our canvas.height, that is the other variable we want to reference, only then do we want to call y++. As long as the bottom of our player is above our canvas height, we're going to keep adding 1 onto that y position. Else we are no longer going to do that. We're just never going to call this code at all. Now this code looks great, but we do need to make sure that we are updating bottom for every frame of our animation because y is always going to be increasing. So I'll take bottom equal to y plus 100. And whenever we add 1 onto y right beneath that, I'm going to make sure that we're updating bottom as well. So let's save this and see how it looks. Go back to our game, and eventually our player will fall downwards, but are they going to stop? Let's find out. And moment of truth, we do stop at the very bottom because this condition is being called. This is a great start to our game. But if we look over here, our code is already getting pretty hard to read. If I were to come back to this at another point in time, I might not know what any of this does. And this is a good sign in which you want to start refactoring your code into something that makes a little more sense. And the best way to do this, in my opinion, is to change what we have right here into a class object. So this class object is going to encapsulate all this code, and it's basically going to allow us to create one individual player, or many in this case, which has its own individual properties, which we can edit, and it makes things a lot more readable. You'll see exactly what I mean by this. But to create a class right beneath canvas height, I'll add in a class identifier and specify my class name. I want this to be a player class. And class names typically have a capital letter to start, so that's why that is capitalized. And now within my player class, I want to call a constructor function. So this constructor function is going to set properties associated with the player that we create. Each player we create is going to have individual properties which are specified within constructor. What properties might a player have? Well, we can figure this out just by looking at our fillRect code down below. We have an x position, a y position, a width, and then we have a height. Those are great properties to begin adding in to our player class. So let's start off by declaring our first property will be this dot position. This is going to be equal to an object with an x property and also a y property. What should x be equal to by default? Well, right now we have it set equal to 100. So we'll add that there, make sure we add in a comma, and then we'll say our y is also going to be equal to 100 because that's what we're defining right here. So a player has an x and y position. The player is also going to have a width. Our current width is equal to 100, so we'll make sure that we're setting that. And then our height is also going to be equal to 100. Now within my player class, I want to define what a player should look like directly within the class. And to do that, right beneath constructor, I can add in a new function. I'm going to call this function draw. Looks a little something like this. This is actually a method if we want to be exact. But now within draw, I want to specify what a player should look like. Right now, a player is defined by these two lines of code. So I can grab these, cut them out of place, and then paste them within draw. So now whenever I create a new player and call its draw method, we're going to call this code right here. But since we're within a player class, we no longer have y available to us, and we no longer have height available to us. At least because they are defined down below instead of at the top of our file. But nevertheless, we want this based on our player properties rather than these variables that we just wrote out. So if we want to make sure that we're drawing this rectangle right here based on our properties, instead of referencing 100, we can reference this, .position.x for our x coordinate, this .position.y for our y, and then this .width for our width. And then finally, we're not going to use the height variable, but rather this .height, the height associated with our player. So if we create a player and call draw, we're going to draw it out. We're not going to move anything just yet, but let's replace our current code with our new player class. So we no longer need y because we replaced it with this .position.y. Let's get rid of this. We no longer need height. We could use bottom if we want. Let's comment this out for now. We're going to keep our clear code, and we can comment out this update code down below. But if we want to actually draw out a player, first we need to create one. And to create one, we create a const called player with a lowercase p to indicate that this is an object instantiation. We're going to create a player from a new player class. And that's what we just created up above. So if we create this player object, now we'll have access to this draw method. And this draw method calls this code right here. So if we want to call that, let's grab our player, and within our animation loop, we'll call player.draw. Let's save, refresh, and now our player is drawn out on the screen, but its properties are not currently being edited, and that's okay. We're going to do that right now. So to edit these properties, update them over time, I'm going to add into our player class an update method. Looks a little something like this. And within this update method, I wanted to define what variables, what properties within our player class should be altered over time. And I know down below, I created some sort of update code with these lines right here. So I'm going to cut these out of place and paste them within our new update method. Uncomment these out, and then run this following code. Now this code isn't going to work because bottom is no longer available to us, but we do want a bottom associated with our player class right here. So let's create this .bottom. And actually, I'm not going to do this .bottom, but rather this .sides, and this will allow us to use a left, top, right, and bottom side. Within the sides object, I'll create a bottom property. Now what is the bottom of our player? Well, it's going to be this .position.y plus this .height. That'll give us the bottom coordinate of our player. And now that we have that available to us, right here we can replace bottom with this .sides.bottom. We're going to get the same effect. So this conditional will run true, but this code inside of it will not. Because y no longer exists, now we're using this .position.y instead. That's what actually controls this new player's coordinates. So I'll replace y with this .position.y. That's going to be added onto for each frame. And now I don't want to set our bottom to this new value. I want to set this .sides.bottom to that value instead, which is going to be used on the next iteration of this update loop right here within this conditional. But we do want to make sure that we're replacing y right here with this .position.y. And I already forgot what 100 is. That is why it's useful to always name your values. So instead of adding on 100, I'm going to add on this .height because that is what our bottom is actually equal to. Our y position plus our height, that is much more descriptive as well. So now what we can do is, right after we call player.draw, we can call player.update instead. So we're going to draw out our player, and then we're going to add 1 onto our y position, and also alter the value of our bottom side. Then we're going to go through the next iteration of our animation loop, which is going to draw out our player in its new position, and then update those coordinates, and it's just going to keep happening over and over again until we stop at the very bottom of our canvas. So let's save, refresh, and now that code works exactly the same. And once we hit the bottom, which we should, we stop completely, so great. Now obviously this is a lot more readable than what we had earlier. We're calling player.draw, player.update with an animation loop. We don't have any floating variables around, and we pretty much replaced all of our values with things that are much more descriptive, such as position, width, and height. But our class code up above is longer than the code we had previously. Even if it is easier to read, it is still cluttering up our file here, so we always want to make sure that we're refactoring as our code file gets more and more complex. we definitely just made it a little more complex by adding in this new class. So to make this a little less complex and easier to read, we can take that new class and cut it out of this file. So now this is a lot nicer to look at than what we just had. But we do need a place in which we can store that code that we just cut out. So in this case, it makes sense to create a new file. And I'm going to paste that code in here. I'll hit Command S to save it. And where do I want to save this? Well, I'm going to organize a little bit in advance, which I don't usually do, but it'll make sense in this case because we're going to be adding in more classes for the rest of our game. Within Kings and Pigs, I'll add a new folder called JS. All of our JavaScript files are going to go inside of here. And I know I'm going to have quite a few, so within our JS folder, I'll create one more new folder called Classes. And I want to store this class as player with a capital P within our classes folder. Let's save that. And now we have this nice little directory structure over here, but we do need to make sure we're pulling in player.js for the rest of our code to read. So to do that, we'll go into index.html, duplicate our script tag here, and then I want to make sure that I'm referencing this file right here of player.js. To do that, I need to go inside of our JS directory, hit slash, go inside of our classes directory, hit slash, and then reference player.js with a capital P. So as long as I've done this correctly, our code should still function exactly as it did before. We save, refresh, and indeed it does. And our player will even stop once it hits the bottom of the canvas, and there we go. So our code is much cleaner here. We have our own player class. We have all of our implementation code within index.js. This is a great start. We're trying to keep our game code as clean as possible. But that's all it's going to take to begin creating our player. We're going to be adding on a bit more right now. But let's go ahead and check off the task of create a player. So now we're going to add gravity on our player. And you might be asking me, Chris, well, isn't gravity already added on our player? Well, the answer is kinda. If we go look at our player over here, yes, our player is moving downwards, but this isn't truly gravity. Gravity is a constant acceleration on the downward velocity of whatever object you're dealing with. So yes, we do have a y velocity associated with our player here, but there is no acceleration associated with it. We're not actually getting faster as we fall down towards the bottom of our canvas. And that gravitational acceleration is going to give off a really realistic falling effect, which is going to really take our game to the next level. So we want to make sure that we add it. And it's also going to be helpful for when we jump with our player that we get pulled back down. So a quick overview for you on gravity. We have our player right here, and we're always going to be moving downwards, right? Well, currently we have a velocity of 1 pixel per frame. We want to make sure that we're increasing this value for each frame. So let's say our gravity is a value of 1. We're going to render out our player right here with a y velocity of 1 pixel. For the next frame, the next iteration, we're going to add on 1. And this will give us a velocity of 2 pixels. So instead of moving downwards by 1 pixel now, we're going to move down by 2. So we just moved a little bit further for the next frame in our operation. So now we add gravity onto this current value right here. Our gravity value is 1. So we add 1 onto 2, we're going to get 3 pixels. For our next frame, we're going to move even further. And as we continue to move further for each frame, it's going to look like we're dropping really quickly at the end to really give off a realistic effect of gravity. This is exactly how gravity works in the real world. It's going to be how gravity works within our game right here. So to begin coding this, we want to create some sort of velocity property for our player class. Let's go ahead and do that now. To create a velocity property, we'll head into player.js. And then within our constructor, we want to add in a property called velocity. We can do that with this.velocity and set it equal to an object because a velocity can have either an x or a y dimension. So our x velocity is going to be equal to 0, and this is what's going to determine whether or not we move left or right. We're not going to use this for now, but we do need a y velocity for gravity. And we're also going to set this equal to 0 because our y velocity is going to be set from our actual gravity value. But this is a good start, so let's save that and head on down to update. So for each frame, we want to call this.position.y, and we want to add on to the current y position with plus equals our velocity value on the y-axis. So by default, since our y velocity is equal to 0, nothing is going to happen with just this code. But if we begin adding on to this.velocity.y, for every frame in which we are above our canvas, we're going to start pulling our player down, and we're going to give off that gravity effect. So we know right here, this is when we're above the bottom of our canvas. We can write that out with a comment. Above bottom of canvas. And if we are above the bottom of our canvas, we want to start adding on to this.velocity.y. I'll grab that with this.velocity.y. What do we want to add onto it? Well, a value of gravity. We'll say we're adding onto this for each frame a new value of 1. 1 is going to be our gravity value. If we're adding 1 onto y, we know that's going to be added on to this dot position right here, which is also used down below. So we need to make sure that we're taking velocity.y into account for our conditional. We can add on to this dot sides dot bottom, this dot velocity dot y, and say as long as the bottom of our canvas plus this new velocity right here is less than our canvas height, then we want to keep adding 1 onto y. And this is going to make us go really fast and even through the bottom of our canvas. And I'll explain why in a second, but let's save this, refresh. Now you can see that we're falling, but with a much more realistic movement. Because we're adding on to our velocity on the y-axis with a greater and greater value, well, it's going to look like as if we're actually falling in real life. But why aren't we stopping at the bottom? Well, yes, we're saying we only want to apply gravity if this is true. But the thing is, even when we stop applying gravity, this dot velocity dot y will still have some sort of value associated with it. So let's say that over here, that when our player reaches the bottom of our canvas, it has a pretty high velocity. We'll say the velocity down here is equal to 5 pixels per frame. Yes, we're no longer adding onto this velocity right here with gravity, but if we keep adding onto our y position right here with 5 pixels, well, we're going to go through the bottom of our canvas. We're just going to keep going no matter what. So really what we want to do is when we stop adding on to our y velocity right here, we want to set our y velocity equal to 0. And as long as we do that, there's nothing else to add on to our y position. We're just going to stop as soon as we hit the canvas bottom, which is exactly what we want. So we know this conditional right here is where we keep adding gravity onto our y velocity. We need an else statement that says what happens if we are no longer adding on to that. What happens if the conditional is no longer true? Well, in this case, we want to grab this dot velocity dot y and set it equal to 0. So we save that, refresh. Now we stop when we hit the bottom. Now we can be a little more declarative with our code over here. 1 is our gravity, and we know that right now, but if we come back to this in a later point in time, well, we might not know what 1 means. So I'm going to replace 1 with a property called this dot gravity. I'm going to assign this up above within our constructor so that I know our player's gravity is associated with this property right here. I'll set that equal to 1, save and refresh, and now we fall down quite nicely. But with this, let's head back on over to to-do and check off gravity. So now I want to move our player around using some keys on the keyboard. And the very first movement we're going to do is a simple jump. Now that we have gravity, as long as we're adding on to our y velocity, we're going to have our player get pulled back down. It's going to be really cool. So let's just start off with the y-axis and add in a jump effect. So to make sure that we're listening for keyboard events, we need to add in what's known as an event listener. And it looks a little something like this. I'm going to go over to index.js, and at the bottom of our file, I'll type in window.add event listener. And then for the first argument, it's going to be a string. I can declare what event do I want to listen for. I can listen for a click event, a mouse down event, a touch event if you're using a phone. But in this case, I want to listen for what's known as a key down event. Whenever I press down on one of my keys, I'm going to respond with the following code. And that following code is going to be declared by adding a comma and then an arrow function. It looks a little something like this. So whenever we press down on our keyboard, we're going to call whatever inside of this arrow function. Now, this arrow function right here takes an argument, and the argument is an event object. This event object contains all the properties associated with the event that just occurred. So let's say I were to click on the screen with a click event. This event object would contain coordinates for where I just clicked on the screen. In this case, we're using a key down event object, so this event object is going to list out what key do we currently press down. We can test this out. Let's add in a console log into our arrow function that console logs out our event object. We want to save this, go back over to our browser, and make sure that we refresh, and then right-click Inspect Element, go over to our console tab, and now, with our window selected, if we start keying down, I'll go ahead and press A, you're going to see this is the event object associated with that key down event. I can open this up, and we can see all the details associated with that, but we really only want to focus on one property here, and that is going to be our key property. You can see I pressed down on my A key. So we can use this to determine how we want to react to certain keys that are pressed. If I press my A key, well, I want to push our player to the left. If I press my D key, I want to push our player to the right. If I press my W key, I want to send our player upwards. This is how we're going to react to events, is by listening for this event object, specifically what key we pressed down. So we know right here, this event object contains the key we pressed, and we can use a switch case statement, which takes a value. In this case, we want to switch out the event.key. The key that we're currently pressing down, create some curly brackets, and then list out a case. if this case is equal to W for me, I want to add a colon to the end of this, and then call break. So I'm going to console log out some text that says I pressed W. I'll delete this console log right there. So what this is saying is take the key that we're currently pressing, and if the key we're pressing down is a case of W, meaning we pressed down W, well, we're going to log out the text I pressed W. Let's save this, refresh, and I'm going to hit A first. I'm going to hit S, and then also D. And you'll see I'm not logging out anything, but once I hit just the W key, now we're logging out that text. So now that we can respond to a particular key, we can declare how we want our player to react. I'll get rid of the console log and then select our player velocity on the y-axis. And from this, I'm going to set this equal to a value of -10. Because if we are moving upwards, we want to make sure our y velocity is negative, because remember, our coordinate system starts at the very top of the canvas, meaning the lower our numbers are, the higher we go. So if we set our y velocity equal to a negative number, it should mean that we're jumping upwards. Let's save this, refresh, and then hit W. And you can see we are definitely jumping upwards. We can even hit W multiple times, go way up, and you might notice right there, well, we just got stuck in the bottom, even though we wrote some conditional code that was supposed to prevent us from doing that. Well, let's go ahead and take a look within player.js and look at our condition right here to see what is going on. So we know if the bottom of our player plus our y velocity is less than canvas height, then only then do we want to call this code, which adds on to our velocity. Otherwise, we should be setting our velocity y equals 0, which has a stop. So why aren't we stopping when we hit the bottom of our canvas? Well, the issue is right here, we are setting this .signs.bottom within this conditional, when in reality we should always be doing this right after we're adding on to this .position.y. Because we know when we're using this .signs.bottom, it is dependent on this .position.y's new value. So if we're using this within the conditional down below right here, we need to make sure that we're using the updated value based on position.y, in which we set up above right here. Otherwise, we're not going to get accurate results. So let's make sure that we move this .sides.bottom right after we call this .position.y. Give it a quick save, refresh, start jumping up, and now we're never going to go past the bottom. We always eventually stop, which is exactly what we want. Now let's say we only want our player to be able to jump once. This is a really easy fix. We can go over at index.js where we wrote out this event listener and say when we hit down the W key, we only want to set our player velocity y equal to -10 if our current player velocity is equal to 0, meaning that we are on the ground, we are not moving at all. So we write out if our player dot velocity on the y-axis is equal to 0, then we're going to call player velocity y equal to -10. Save, refresh, and now when I try hitting W in succession, it doesn't really work, but if I do it really fast, we might be able to get one that works, because once we hit the very peak of our jump, which is going to be right about here, well, our velocity on the y-axis could be equal to 0 at this point in time, which means that if we were to hit W at that exact point, we could jump again. But the odds for that are very low, and it's a little more complex to make sure that does not happen. But I think for our game right here, this is totally okay. We still have it good enough where we're preventing players from jumping multiple times. So we have our jump with W. Let's go ahead and make sure that we jump a little higher because I want a little more bounce to this. I'll set our player velocity on the y-axis equal to -20 instead. Refresh. And I do like the jump for that, so great. Now it should be noted when listening for keys, I'm currently using an American keyboard, so I'm going to be using WASD to move my player around. Now if you're international, you're going to have different keys associated with your keyboard, of course. So just make sure you're using whatever keys are comfortable for you for moving around. And if you ever don't know what key to listen for, just make sure that you console log out event.key. When you press down and open up your console, you're going to be able to see that exact key value. But let's start moving our player to the left and also to the right. If I want my player to move towards the left, I'm going to listen for an A key. So let's add in a case of a colon, and then a break. This is going to move player to the left. And then I want to also listen for when we're moving to the right. So I'll add in a case of D, add a colon, and then a break. And inside of this, say this is when we move a player to the right. So how would I actually move a player to the left or to the right? Well, we need to set the player's X velocity. So if I were to try moving, let's start off with the right. I would go grab our player, get their velocity on the X-axis this time, and set it equal to a value like 5. So when we press down D, we should be moving to the right 4 pixels per frame. But if we try this after saving, nothing is going to work simply because we haven't implemented how our player should be moving in reaction to this X velocity. So over in player.js, we need to alter our player blueprint a little bit more. So yes, we are adding on to our y velocity right here, but even before that, I want to add on to our player's position on the x-axis. And I'm going to add on to this our current player velocity, but on the x-axis. And that should be all we need to get started. So we save both our files, we refresh, we hit D, and now we are moving to the right. But if I hit A, well, we're not moving to the left simply because we haven't implemented that within index.js. So what happens when we hit a key of A? Well, we want to change our player velocity on the x-axis, but in the opposite direction. So all we need to do is add a negative sign right here, save, refresh. Now when I hit D, we go to the right, but now when I hit A, we go to the left. And we can switch between the two, but we're not really stopping. How do we actually stop our player? Well, here's one way to do it. We can add an event listener that listens for when a key is up. So when we release a key, we can say, hey, was that key A? Was that key D? If it was, we want to stop our player's velocity on the x-axis. Let's add in that new event listener. To add that in, I'm simply going to copy this whole event listener right here, paste it down below, and then replace key down with key up. So I don't care what happens when we key up on W, I'm just going to delete that case. But when we key up on A or D, I don't want our velocity on the x-axis equal to -4 or 4, I just want it equal to 0. I want to stop altogether. So save this, refresh, hit D, and now when I release our D key, we stop. Hit A, when I release the A key, we stop. But there is an issue with this method. Can you guess what it is? Well, watch what happens when I hold down on D, hit A, and then I release on A. I'm still holding down D, but I'm not going to the right even though I never released it. So if we're to use this method, whenever we pull up on another key, even if we try going to the other direction, it's going to stop our movement altogether. So rather than just determining our movement within this event listener right here, I want to determine our player's movement within our actual animate function. For each frame that we loop through, we're going to be listening for what key is currently pressed down, and if any keys were pressed, even if we lift up another, we're still going to be activating the code for that one key that is currently down. So if I want to listen for within our animation loop a particular key, here's how I like doing it. I'm going to delete this comment right here and create a const called keys. This is going to be equal to an object, and within this object, I'm going to list out all the keys I want to listen for. So I have our W key. This will be equal to an object with a pressed property set to false. So is the W key pressed? By default, no, it's not. Same for A. This will be equal to an object with a pressed property. By default, it is not pressed. And same for D. By default, this pressed property will not be true. So now based on these properties right here within animate, I could say if keys dot D is pressed. So if our D key is pressed, I want to set our player velocity on the x-axis equal to 1, which means we should be moving to the right. Else, if our keys.a is pressed, I want our player velocity dot x equal to -1, meaning we are going to move to the left. And it looks like I messed up this else if a little bit. Let me fix that up real quick. But if we're going to be listening for whether or not D or A is pressed, well, we need to make sure that we're changing these values whenever we press one of these keys down. Right now, we're just directly setting our velocities. So let's change that. We're going to get rid of this right here and replace it with keys.a.pressed is equal to true when we press down our A key. And then when we press down our D key, we want to make sure that we're setting keys.d.pressed equal to true. And now we can set these properties equal to false within a key up. So we'll get rid of this right here. For D, when we key up on D, we're setting keys.d.pressed equal to false. And when we key up on A, we're setting keys.a.pressed equal to false. So based on these conditions, when we go through our animation loop, we're either going to move our player to the right or to the left. We do need to make sure that we're setting our player velocity on the x-axis to 0 before we actually set it equal to 1. So before we call any of this, we're going to always set our player velocity on the x-axis equal to 0. Then when one of those is pressed, that's when we set it to begin moving our player either left or to the right. So let's save this, refresh, and now when I hold down D, we are moving to the right. When I hold down A, we're moving to the left. And when I key up between the two, we no longer have any jitter, which is great. That's exactly why we're doing this in the first place. I can hit W, we still move up. Our game is looking great. But I will say this is quite slow, so let's go back to a faster rate. Our velocity on the x-axis will be equal to 5, so we'll change that in both locations. And we can clean our code up even further. So since we only have one statement right here within our if statement, we do not need curly brackets, we can get rid of those. And this is a lot cleaner because now we just have one line instead of 3. And we can do the same thing for our else if statement, get rid of the curly brackets because we only have one statement right here. And now we know exactly what is happening when we press down either a D or an A key. The next thing I would do is move our event listers to a separate file, just to make sure that index.js is our main code implementation. So let's grab our event lister, starting down here on line 65. And on line 35, I'll cut all this out, save index.js, and then I'm going to go to File, New File, and then paste in that code, hit Command S, and then save this within my JS folder as event listeners.js. Save that. And now that I saved that within its own file, I want to make sure that I pull it into our game so that it's actually usable. And to do that, I'll go to index.html, and then right above index.js, I'll add in js/event listeners.js. So I'm referencing the correct location right here. I want to save, refresh, and we have a great start to our physics implementation. So this is exactly what we want to begin adding in player movement and gravity. We can go back to To-Do and check off player movement. Next up, we're going to focus on a background sprite. So a sprite is basically just a fancy word for an image. I want to get a background image in the back of our game right here. How do we begin doing that? Well, I'm going to start over in index.js, and I'm going to create a class directly in here. We'll start refactoring as we go, but to create that class, I'm going to go right above player. And that class is going to be called Sprite with a capital S. So this is going to be basically a generic image class. We're going to have lots of sprites within our games for things such as our player, things such as our doors that we enter, new levels, and so forth. So I want to create one generic object which I can use for all these different things we're about to load into our game. So we have the sprite class. Now what properties does a sprite have? Well, I can think of one immediately. It's going to be a position. Where do we want the sprite placed on the screen? The image placed on the screen, that is. So let's create a constructor so we can add in that property. I'm going to create a constructor, and then I want to assign a this.position equal to a position we're going to pass through the constructor. So whenever I pass through properties within a constructor, I like doing it with an object as the only argument, and this way I can easily define what I'm passing through here when I actually create the object. It's going to make more sense as we go through this, but just bear with me. So we're creating a position, assigning it to a position property because all of our sprites are going to have that separate position, but the most important property here is going to be this dot image. So a sprite is, like I said, basically just an image. To create an image within JavaScript, we want to use a native image object. It looks a little like this. We're assigning a new image over to this dot image. Now to load in an image from some sort of source file, we want to declare that this dot images dot src, the source of this image, is equal to wherever that file exists within our project. So right now we don't actually have any images, and that's a problem because what are we going to put in for our background if we don't have an image? Well, I created an image using Tiled, a map editor, and that image is going to be available to us over on Google Drive. So check the course description, make sure you're on Google Drive right here. We want to go and download this image folder. This is going to contain all the images that we need for our game. So I'm going to right click IMG and then hit download. And you can see down here that's preparing the download, and once it's ready, it's going to download to my Finder. So I'm going to call this Kings and Pigs Assets. Make sure I hit save, and that's going to download. So once that downloads, you can open up your Finder, open up that zip file, and there is our image folder. So I want to grab all these images, and then while I'm holding down Shift, I'm going to click the very last thing. With that, I'll hit Command C to copy these, and then find our Kings and Pigs folder. It's going to be right here. Within this, I want to create a new folder. This is within our project called IMG. This is where all of our images are going to go. So I can hit enter, and with this selected, I can hit Command V or Control V if you're on Windows, and all those are going to be put directly within this folder, which means they're available to us within our project. And we can see Sublime Text Update over here. Now we have access to all these different images. Now, what image do we want to select? Well, background level 1 is going to be it. If I click on this, this is what it looks like. This is going to be the background for our game, at least the very first level. So inside of index.js, I want to make sure when I'm setting .source right here, that I'm setting it equal to wherever that image is located. So let's go from index.js into our image folder, and then we want to select background level 1. It has a capital L and then 1.png. So now when we create this image, it's going to be equal to background level 1. Now that is great, but we actually want to draw this image out. Right now we're just storing it inside of this .image.src. We want to make sure that we're rendering this out. So to do that, we're going to add a draw method. And within this, we can call our canvas context with C, and then call draw image. So the very first argument for drawImage is going to be the image we want to draw out, and it has to use this JavaScript image object, in which we already set its src. So let's grab that and put it within our first argument with this .image. Now the second and third arguments are going to be position on the x and the y axis. And we're already setting that up above, so let's reference it with this .position.x, and then the third argument will be this .position.y, that is going to be our y position. Now with this, as soon as we create a sprite, we can call draw and render it out on the screen. Let's do that next. So down below, right above player, I'm going to create a new const called background level 1. And this is going to be equal to a new sprite object. Everything is going to be set automatically. Besides position, we do need to make sure that we're setting that manually. So let's pass through an argument. It's just going to be an object. And then I need to grab the position property. So I'll grab that and assign it equal to an object like so. So by using this object syntax right here, instead of not knowing what we're passing through as the first argument, we'd pass through an object right here with an x and a y, and that would define our position. But we don't know what this means without that position label. So when we add position right here inside this object syntax, it requires us to add a label like so, and now we know exactly what this object is equal to. It's going to be equal to a position. It makes our lives easier because our code becomes more descriptive. So we have a position, and it's going to take an x, which we use right here. An x by default I'm going to set equal to 0. And then y I'm also going to set equal to 0 because we want our background drawn on the very top left-hand corner of our current canvas. So now we have a sprite object assigned to background level 1. With this, we can call its draw method. So let's grab this, and then go inside of animate, and where relative to everything else would we want to draw this out? Well, I think it makes sense to draw this out as the very first thing. We might not even need this fill style fill rect code anymore, because our background should take up the full canvas width and height. So let's draw this out by selecting our background level 1, calling draw, saving, and then heading back to our game, give it a refresh, and there is our background image. It's going to be that easy. So this looks great, but there are a few things that I would do before moving on to the next lesson. And the first thing I would do is just get rid of c.fillStyleWhite and c.fillRect. These are two lines that we no longer need because our background is going to be drawn, basically clearing everything else from the canvas. So let's save that, refresh, and you can see we're getting the same effect. We didn't need those two lines of code. What else would I do here? Well, when we're passing through a position, it also makes sense to pass through an image src, stands for image source. So now whenever we create a new sprite, we can assign that a different image, and that way we don't have to be stuck with always rendering out our sprite with background level 1. We want to make sure that this is scalable and that we have a variety of images in which we can put in our game. So I'm going to cut this string right here that has our background level 1 PNG with Command X, and then I'm going to set image.src equal to image src. But now I need to make sure when we create a new sprite that we're creating the image src property and set that equal to the string in which I just cut out. So given that we did this correctly, we can save, refresh, and everything still works. But now only this one sprite right here is going to have the background image of background level 1. That's perfect. Another property I would add in here is going to be this .loaded, set it equal to false. This is going to determine whether or not our image has been loaded fully. Whenever we call draw right here, I only want to call c.drawImage if this .image is completely set. And I don't know if this is actually set until our image is loaded. And we want to make sure that when this image is loaded, we set this.loaded equal to true. Because if this .image has not loaded, well, this method right here just won't work. So right before I call c.drawImage, I want to write a conditional that says if this .loaded is false, which we can check for with a bang operator, then I want to return completely, meaning I'm not calling any code that follows this statement right here. It's basically just another way to say if this image is loaded, and we're going to contain everything within these curly brackets, but it's a way to do away with those curly brackets and make our code a little more readable because we don't have to add any indentation here. But if we want to use this syntax right here, we always need to make sure that we add in the bang operator to do the inverse of this condition. So now we need a way to set this .loaded equal to true, which we can do by selecting this .image.onload and set that equal to an arrow function. So whenever our image loads, we're going to call whatever is inside of this function right here. And what do we want to call? Well, simply enough, this .loaded is equal to true. We know that our image is loaded. We're going to use this to determine whether or not we actually render it out. So we save this and then refresh over here, and it looks like we're still good to go. Now the very last thing I would do is simply refactor this into its own separate file. So we just created the sprite class. Let's select it, cut it out of place, and then I'm going to add this into a new file within our classes folder. So I'll save index.js, go to File, New File, paste in that sprite class, hit Command S, go inside of JS, go inside of classes, and then create a new file called sprite.js. So whenever you create a new JavaScript file, you need to make sure that you pull it into index.html, otherwise it's not going to work. And I do want this available to us before we load our player class, because our player class might start inheriting properties from our sprite class when we want to add in images. So let's copy the script tag, paste it up above, and then I'm going to pull in our sprite class, which can now be used across all these different files. So we just want to make sure that this works. Let's save and make sure that index.js is saved as well. Refresh, and we are good to go. Looking in great shape with that new sprite class. So if we go back to do, we're going to be able to check off background sprite. So the next thing we're going to do is add in collision blocks. Now, what is a collision block in the first place? Well, if we go back to our game over here, a collision block is basically going to be one specific area that looks like this, a small little square in which if our player touches this, they cannot go past this boundary. And we use collision blocks to basically determine the area in which our player can and cannot travel. So if I wanted to basically make sure that our player cannot travel past this inner rectangle that we have right here for our map, I would create collision blocks all along its boundaries, even going upwards here. And once I create collision blocks all around the boundaries, well, we write collision detection that says, hey, if my player runs into one of these right here, they cannot go past that point. Now we could create collision blocks manually directly within our code, but we know that we want to have multiple levels in this case, so it makes sense to generate these collision blocks using a map editor. And that map editor in which we're going to use is called no other than Tiled. So this is a free map editor in which you can download. I have tutorials on how to go through this whole entire thing. Maybe I'll explain more in a premium tutorial with this direct course, but I really recommend checking out the Pokemon course if you want to learn how to use Tiled in depth. But otherwise, just make sure you download Tiled and open it on up. Once you have Tiled open, it's going to look a little something like this. We want to open up a new Tiled map. And if you check out the Google Drive link, you're going to notice inside of it we have a Tiled folder. And here we have a maps folder which contains all the maps for the map we're going to use for this specific game. We want to open up level1.tmx. So let's double click on this, scroll back on over to Tiled, and you should have this map open automatically for you. If any errors show up, just make sure that you click OK. It should load all of the assets because they're relative to where the map was placed within Finder. So this is what our map is going to look like, and you'll see that I have a few layers over here on the top right. We can turn things off like our tiles, our decorations, and I intentionally place these within their own individual layers so that I can separately export my collisions layer right here. The collisions layer consists of just these red blocks that surround where our player should and should not be able to move. So once our player is spawned in here, we don't want them to leave this area, and we don't want them to be able to run through these blocks right here. That is why I drew collisions in those locations. And again, if you want to learn more about Tiled and draw out your own map, really check out that Pokemon video. But otherwise, the main thing we want to do right here is export the data associated with these collision blocks on this collisions layer. So to export this data within Tiled, all we need to do is go to File, Export As, then we want to go over to Downloads. This is going to be a temporary file, and I'm going to save this as collisions. So let's save that, and then head back on over to Finder. So once we're in Finder, we want to go to Downloads where we save this, and then we're going to open up collisions.js. So let's double click that, and this is what this file looks like. So this contains all the data associated with all of our layers that were created within Tiled. This layer right here is our background layer. Down below we have our tiles layer, and we're just going to keep scrolling until we find our collisions layer. So what we want is this array right here. This array consists of every location in which we want to place a collision block. But to do this, we need to parse this data out within our own game, and then make sure that we're rendering collision blocks in the exact locations, wherever we see a symbol of 292, because that is the representation within Tiled of what a collision block is relative to all the other tiles within there. So let's start by going to our collisions layer and grabbing the data right above it. I'm going to get the whole array, hit Command C to copy that, get rid of that file for now, and then head back on over to our project. So I want to create a new file to store this array. I'll go up to File, New File, paste that on in, and then hit Command S. And then where do I want to save this? Well, within JS, and I'm actually going to create a new folder called Data. And then within Data, I'm going to save this as collisions.js. So let's create a new const called collisions level 1, set it equal to the array, and there we go. We're off to a great start. So what's next? Well, basically, we need to parse our array right here into a 2D array. Why and what does that even mean? Well, let's visualize this. each 0 right here represents one cell within our tiled grid. And if we look back within tiled over here, this grid is 16 blocks wide and 9 blocks high. Each of these cells right here is 64 pixels wide by 64 pixels tall, and this is the exact same size in which we're using for our actual canvas. This is 1024 pixels wide by 576 pixels tall. So referencing that array I was just showing you, if we're just focusing on collisions right here, we know the start of that array was something like 0, 0, 0, 0 repeating. So that first 0 is going to represent this cell right here. We're just going to keep going and filling this in with 0 until we reach the very end of this row. So all of our zeros go to the very end, and what's next? We move to the following column, and we keep adding in zeros, and we're going to keep adding in zeros until what? Well, until we hit a collision block. So 0, 0, 0, 0, 0, and now we have a collision block right here. So what symbol are we going to put here instead? Well, something like 292. That was the symbol that tiled automatically assigned our collision blocks. Every red collision block that we have right here is going to have 292. We're just going to keep going until we go over here. That's going to be 0. This is going to be 0. And then this will be 292. So this kind of shows you how that array was laid out. We can go back and view that with this in mind to see that we have a ton of zeros in the beginning until we hit 292. And then all of our 292s fill out that entire row of where our collision blocks were until we go on to the next row where we have 0, 292, and so forth. We want to parse all of this into a two-dimensional array. So right now, everything is just within one giant array until we hit the very end. And then for each row, we're going to put all these cells within a subarray. So we loop through all of our objects and we say we want the first row put into this array right here, the subarray. Once we loop through those objects, we're going to go on to the next objects and put all of those within their own subarray. Basically, we're going to go through every single row within this grid right here and keep putting all these symbols within their own individual subarrays. And what this is going to allow us to do is precisely place these blocks in the exact location based on the indices of our rows, which is going to be 0, 1, 2, 3, 4, and so forth, and based on the indices of our columns. So 0, 1, 2, 3, 4, and 5. And really the only way to get these indices is to put everything within a 2D array. So we have our rows, which are going to be represented by our subarrays, and then we have our columns, which are the actual symbols inside of the subarrays. So if this doesn't make too much sense right now, it will make more sense as we begin writing out the code, but that should give you a general idea of the logic going on here. So let's start by parsing our data into a 2D array. How do we go about that? So what I can do is run this through a function called parse2d, and then pass through our data. And it will look a little something like this. And there's a way in which we can make this function a bit cleaner. I know a lot of people might have some flack with this because they're going to say you should never alter the default objects that come with JavaScript. But honestly, this does make our code more enjoyable to use in my eyes, so I really don't care about that advice. So instead, I'm going to get rid of this function and I'm going to reference our main array prototype. So this array prototype basically contains all the methods that we can put within an array object. So we have an array right here, and we could call methods on top of this such as filter. We can call things such as slice, and so forth. If we want to add our own method on top of this, we basically need to assign to our array.prototype a new method, which I'm going to call parse2d, and then assign to this new method a new function. And I'm not going to pass anything through this because I'm going to have access to the data, in which we call parse2d on, and to access that data, all I need to do is call this. But that's not what I want to do to start. What I'm going to do is create a new array within this function. I'm going to call this our rows, because this is going to contain all the subarrays that make up our main rows object. So the next thing I want to do is start looping through these values right here. How do we loop through these? Well, I can loop through them with a for loop. And to start a for loop, we need to declare a let. I'm going to set I equal to 0 to start. This is a traditional for loop where we start from the beginning. And say I want this to loop for as long as I is less than this dot length. So the length of the array in which we're going to use parse2d on, which is going to be this right here once we call the method. And then I need to add a semicolon and state how do I want to start looping through this array. Well, for every iteration I want to take I, and I'm going to add onto I 16 values because I know each row within this data right here is going to be representative of 16 cells. So then I want to add some opening and closing curly brackets. And now I can select our rows array that we created up above and push into this some subarrays. So how would we create a subarray where we grab the first 16 symbols within collisions level 1? Well, we can do this by selecting our data with this and then calling a slice method. The first argument of a slice method is what index do we want to begin slicing elements from. Well, we want to start at the very beginning, which is going to be 0, but eventually we want to start over on 16, which might be something like this right here, to begin the new row. So we need to make sure that this value right here in which we're slicing at changes for each iteration of our loop. So I actually want to say the very first index in which we want to begin slicing from is going to be I. That'll give us an index of 0 to start. And then we need to determine as our second argument, where do we want to slice to? What index? Well, we want to slice to wherever the 16th element is within this array. And we can say that we want to do that by grabbing I plus 16. So to start, we're selecting 0, and then we're selecting 16, which will give us the first row of 16 elements. Once we go through the next iteration of this loop, we're adding 16 onto I, so this would be 16. And then what happens? Well, we slice out from 16 to 32. We're going to keep going until I is greater than this dot length, which means there are no more elements to select. We reached the end of our array right here. But this is how we're going to parse everything into their own row, in which we can then return and use to start creating those collision blocks. So just this right here is actually going to create a full 2D array for us. So now we want to return the value of rows, and then we can assign that to some new constant or some new let. So I'm going to save this, and then right beneath it, I'm going to create a const called parsed collisions. And parsed collisions is going to be equal to collisions level1 dot parse to d. And make sure that d is uppercase because that's how I declared it right here. But now we're going to run all this code on this array in which we selected and store it within parsed collisions. So we want to make sure this works. Let's console log this out, console log out parsed collisions. And to make sure this file is even read in the first place, we need to make sure we're pulling it in within index.html. So I'll copy a script tag, paste it up above, and then make sure I'm referencing the correct file. So within our JS folder, I want to go inside of data because that's where we store this, and then reference collisions.js, and that is indeed what it is. So let's save this, go back to our code, and to view that data, I want to right-click, go to inspect element, open up our console, and now I can open this on up, and notice we have an array with 9 rows inside of this. That's exactly what we wanted. Each of these rows is exactly representative of what we were drawing out over here in tiled, where these first 2 rows have a symbol of 0. 0 just means we don't draw anything out as we loop over those. But once we go into row, which actually has an index of 2, you can see we're starting to list out the symbols of 292, which are going to represent where we place a collision block. Once we go on to row number 4, you can see we only have basically 2 of those within this row. It's a 1-to-1 representation of what we actually draw over here, and it'll allow us to draw collision blocks in their exact location on our actual game map. So to draw our collisions on our map, we're going to start looping through these. If we hit the first row, we go to the very end, and then we proceed on the next row, go to the very end, and finally we hit a symbol of something like 292. We want to say, draw some sort of collision block at that exact object in that exact location based off the indices of our row and the column we're currently looping over. So how do we begin looping through these within code? Well, back within collisions.js, now that we have our collisions parsed out within a 2D array, I want to start looping through these. And I can start looping through these by grabbing the array of parsed collisions and calling for each on top of it. So what I'm saying here is for each row within this array, I want to console log out each row. Simple enough. Let's save this, refresh, and see what it looks like. So now we're console logging out each row for each iteration in which we're looping through parsed collisions. So we have the row, now we want to grab the individual data piece. To grab that, within this, we're going to select that row and call for each. So for each what inside of this row? Well, for each symbol inside of this row, I want to console log out that symbol. Save that, refresh, and now we're console logging out each symbol individually, and we can grab this symbol to say we want to draw an object only when we hit a symbol of 292. We're going to do exactly that. Within row.forEach, I'm going to say if our symbol is equal to 292, then I want to draw out a new collision block. But we don't actually have a collision block object just yet, but to start, we can comment out here, we're going to push a new collision into collision blocks array. So let's begin by creating a new collision object, and we can do that right here within collisions.js and start refactoring things as needed later on. So I'm going to create a new class called collision block with a capital B. This is going to take a constructor, and what do I want to pass through for each individual collision block? Well, definitely one object with a position property, because each collision block is going to be moved around in different locations independent from one another. So whenever I pass through position, I want to make sure I'm assigning it to a this.position property, like so. And what else might a collision block have? Well, it might have a width, which I can assign with this dot width. And I want to set that equal to the width of our actual blocks as they are over in tiled. Those are going to be 64 pixels wide, and then for a height, it's going to be 64 as well, 64 pixels tall. So I believe those are the only properties we need to get started, but we do need to add in a method called draw so we can actually see these. And what does a collision block look like? Well, it's simply just a square, so we can create this with c.fillRect, and then we can put inside of this the properties in which we just created within our constructor. So our x-coordinate is going to be this .position.x, our y-coordinate is going to be this .position.y. Of course, our third argument is going to be our width, so we can reference that with this .width. And then finally, our fourth argument will be this .height. Now, I do want to make sure that these are red, so they represent the exact color in which we're using over in tiled. And I can declare that with c.fillStyle is equal to red. And that should be all we need to get started with some collision blocks. So now we have this collision block class, we can begin pushing these into a collision blocks array. Let's create that array with const collision blocks, set that equal to an array. And now whenever we hit a symbol of 292, we want to select that new array and push in a new collision block. So how do we determine where we should be placing this new collision block? Well, we want to pass through our position property, like so. And position is going to have an x, which I'll set to 0 to start, and a y, which I'll also set to 0. Remember how I was referencing the indices of what row we're on and what column we're currently on. We want to use those to automatically generate the position in which this block should go. So if we want to get those indices, as a second argument for the function within for each right here, we can add in next to row an index argument. And I'm actually going to call this y instead, because this is going to be our y index in which we're currently looping over. So this y right here is going to be equal to something like 0, 1, 2, 3, 4, 5, 6, 7, and 8. And with that index, we can use it to set our y property when we create a new collision block. So instead of referencing 0, I'm going to reference the y, the current index in which we're looping over, and multiply that by the size of our block, which is going to be 64. So to really hammer this in, let's say that our index is going to be 1, this right here. If we multiply 1 by 64, we're going to get a value of 64. We're saying place our block at a position y of 64. Where is that? It's going to be right here. But we don't actually have a block in this position because there is no symbol of 292. So only when we hit an index of 2 are we going to place a block. 2 times 64 is going to be 128. 128 pixels from the top of our canvas right here is going to be in the exact location in which we should be placing one of these collision blocks. This is just going to keep looping through our rows over here and making sure that our y-coordinate is perfect for every single one of these blocks that we have within our map. So we have y set up. How do we get x set up as well? Well, when we loop through each row, we also want the index of the column we're currently looping over. And I'm going to assign that index a name of x. This is going to be our x index. And now that I have this x index, I can assign that x position equal to x times the width of our block, which is 64. And it's going to make sure that we're pushing our block over to the right by the perfect amount so that we're getting a one-to-one representation of our collision blocks as we got them over in tiled. So let's make sure that we save collisions.js, and then I want to grab our collision blocks array in which we just populated. I'm going to go over to index.js, make sure that I call this within animate. So right after we call background level 1 draw, I'll reference collision blocks, call for each on top of this. We're going to loop over every collision block within this collision blocks array. So I can say for each collision block within this array, I want to call the following code, collision block dot draw. So when we call this draw method right here, we're actually calling the draw method that we created within collision block, which just creates a simple red square. So let's make sure that we save index.js as well as collisions.js. I'll exit out of our console, refresh, and now all of our collision blocks are drawn in their exact perfect locations relative to what we had over here in tiled. Now you might not want these to be the full opacity as we see right here, especially for development purposes. It's kind of useful to see what's behind these blocks. And if that's the case, we just need to change our fill style for the collision block. We can do that by assigning this equal to RGBA instead of red. So on a value from 0 to 255 on how strong our red is going to be, I want this equal to 255. I want our green value to be equal to 0. I want our blue value equal to 0. This is basically red right here. But this last argument, alpha, is going to be how transparent this color is. I want it about halfway transparent, so assign it equal to a value of 0.5. This ranges from 0 to 1. 0.5 is 50%, and if we change that, now we can see everything behind these collision blocks. And eventually we're going to get rid of these altogether. They're just going to be invisible running in the background. making sure that our collision is in place. But before we move on to adding in collision, I want to make sure that I'm refactoring this so that our code is as clean as possible. So really, what would I do here? Well, I don't think it makes sense to keep our collision block class within collisions.js, even if they are related, because I might want to use this somewhere else within our game. So we'll take the class, cut it out with Command X, save collisions.js, and then I want to go to File, New File, paste that in, and I want to save this within our classes folder. So I'll save this as collision block, like so, and whenever I create a new class, I need to make sure that I pull it in to index.html. So I'll save this right above sprite.js, reference a collision block file like so, but this won't work right off the bat because we're trying to use this collision block class within collisions.js, as we can see right here. So we want to make sure that this collision block generation code right here is actually referenced within index.js. So I'll cut it out of collisions.js, go over to index.js, and where do I want to put this? I think I'll put this as the very first thing after we set our canvas width and height. This is an okay location. I like where this is, and let's save and refresh, and everything still works with that. But we can clean this up even further. Within collisions.js, I want to put this parse2d prototype within some sort of utils file because this is more like a utility function. If I ever want to reference this later on, it might not be apparent to me that this is within collisions.js. So let's get it out of here. I'll cut this out, and then I'll go to New, File, paste it in, hit Command S, and I'm going to save this in our JS folder as utils.js. Whenever you create a new JavaScript file, you need to make sure you pull it in. So I'm going to pull this in as the very first thing, even before collisions.js. Make sure I get rid of data right here and reference utils.js instead. So we save, refresh, everything still works, looking great. Collisions.js now just contains our collision data, and utils.js contains our parse2d function. So over in index.js, one more thing I would do, very last thing for this lesson, is I would refactor this into something that is a little more readable, because this is a lot to take in on first glance. If I were to come back to this in a later point in time, I might not have any idea what this does right here. So it's kind of an indicator that I want to refactor this into its own function. I really like using this dot object notation on my method. Screw the haters. So I'm going to grab this dot for each right here and go inside of utils.js and create a new array prototype. So I'll reference our array prototype, and then I'm going to call this create objects from 2D and assign that equal to a new function, like so. So inside of this, I'll paste in that for each in which I just cut out, and where we had parsed collisions, I'm going to replace this with this. This is going to reference the array in which we're currently calling this code on. Now, looking at this code, it doesn't really make sense because we don't have a collision blocks array in which we can push in new collision blocks, at least not anymore. So we want to make sure that we create that whenever we call this function. I'm going to create a const, and I'm just going to call this objects because we might use this for other things instead of just collision blocks. And I'll set objects equal to an empty array. Now, whenever I loop through a symbol of 292, I want to push into this objects array a new collision block. This is totally fine to start. And now when I get to the end of this function, I want to return the populated objects array. So now all I need to do is grab .createObjects from 2D, go back to index.js, and on top of parsed collisions, I can now call createObjects from 2D, which will parse everything out and return to us a collision block filled array. So instead of assigning collision blocks to an empty array up here, I'm going to get rid of that, create a new const down below called collision blocks, and assign that equal to parseCollisions.createObjects from 2D. As long as we did this correctly, we can save, refresh, and everything is still going to work exactly as expected. But our code within our implementation is much cleaner because we're calling array methods instead of trying to understand all this code right here on first glance. So I think that's all I would do to make sure that our collision blocks are rendered out on the screen. Let's head back to To-Do and check off collision blocks. Next, we're going to add in collision detection. So how do we start detecting whether or not our player has hit one of these blocks, and what do we do in response? Well, I think it makes sense to start illustrating this out to really help you grasp the concept. So I'm going to zoom in here. Let's say that this blue block right here is going to be our player. This is equal to this. And say that we are focusing on frame number 1 before we have even applied gravity. So before we apply gravity, which is going to push our player down, we hit an arrow key to the left, which means our player's position is going to go over 1 to the left. Now we can see that we have some overlap here between our player and one of our collision blocks. So basically we're going to loop through each of these collision blocks, and then if one of these collision blocks has some sort of collision with our player right here, we're going to run some code that pushes our player's edge right here to the far side of whatever collision block we're currently colliding with, which is going to be this one. So we're first going to detect for collisions on the x-axis. So that's going to be step number 1, is to check for horizontal collisions. Only after have we checked for horizontal collisions do we want to apply gravity. Because if we apply gravity before we check for horizontal collisions, we might be in this location right here where we are colliding with 3 collision blocks instead of just 1. And then we need to determine which collision blocks should push our player back to this location, and it's just not going to happen if we do things that way. So we check for the X collision first, push our player back to this location, and then we push our player down with gravity, so we might be over here. So that's going to be the second thing we do, is apply gravity. After we've applied gravity, we want to check for vertical collisions, which obviously we have one, and based off of this one block down here in which we're colliding with, we're going to push our player back up. So for step number 3, we check for vertical collisions. And this is going to be the end of our loop. So as long as we go through these 3 steps, we're going to go back to the very beginning, call draw, update, whatever it might be, and do the exact same thing. And as long as we keep doing this for every frame, we're going to make sure that our player cannot move past these blocks and that we always run into them without any weird bugs or stutter effects like that. So how do we begin coding this? Well, in order for our player to interact with these collision blocks, we need to pass those collision blocks through into our player class. That's a great way to begin looping through these blocks while referencing our player's properties. So let's start with that. To pass these blocks into our player class, we're going to go inside of player.js, and inside of constructor, I'm going to add in an empty object. And I know I want to pass through this object a collision blocks property. And by default, I can say this is going to be equal to an array, just to give me some further detail in regards to what a collision blocks property is. It's going to be an array. So once I pass through collision blocks, I want to make sure that I assign a new property called this dot collision blocks equal to the collision blocks argument we're passing through. And now within our implementation, I just need to make sure that these collision blocks are available to us. So let's head on over to index.js, and where are we creating our player? It's going to be right here on line 18 for me. Now I know I can pass through an object with a property of collision blocks, and what do we want to pass through here to the collision blocks property? Well, no other than the collision blocks in which we parsed out up above. Now the cool thing is, if this name right here, this const name, is the exact same name as the property name we're trying to pass through to our player class, we do not need to add collision blocks to the end of this. Since these have the same name, we can just get rid of the colon, collision blocks, and this right here is the exact same thing as this. Just a cool little JavaScript shortcut for you. So let's use the shortcut version, and to make sure this works, I want to console log out this dot collision blocks, which should be set when our player is created. So let's right click, inspect element, go to console, refresh, and there are all of our collision blocks. So great, we know that works. Now we can begin looping through these directly within our player class. Now where do I want to begin looping through these? Well, within our update function right here. Update is basically going to contain the steps that we wrote over here. So the first thing we want to do is check for horizontal collisions. We check for horizontal collisions right after we add on to our X position. So we pressed A or D on the keyboard and our player moved left or right. Right here, we check for horizontal collisions. So as I mentioned, we want to loop through our collision blocks. And we can do this in a few ways, such as using for each, but we want to break out of this loop as soon as we realize our player is colliding with one of these blocks. So if we ever want to break out of a loop, it makes sense to use a traditional for loop in this case. So I'm going to create one with for, declare a let I, set it equal to 0, and say I want to loop through this as long as I is less than this dot collision blocks dot length. And for our third statement right here, I'm going to say increase I by 1 for every iteration. So this right here is the exact same thing as this dot collision blocks dot for each, but the difference is with this traditional for loop we can use a break statement to break out of the loop completely, and with dot for each we cannot use that. That is not available to us. So that's why we're using this traditional for loop, but we do need a way to reference each individual collision block we're currently looping over. And we can get that by declaring a const called collision block, just one, so singular. This is going to be equal to this dot collision blocks, the array we're currently looping through, and we can grab one item from this array by referencing the index in which we're currently looping over. So we're going to put I inside of here, and now this truly is the same thing as dot for each. We can reference collision block right here and start using this to check for collision between this one block we're looping over and our player's position. So I want to begin by creating an if statement. This is going to say if a collision exists. How do we determine if a collision exists? Well, let's go back to our game over here. We just moved our player over to the left, and visually we can see that a collision does indeed exist. But how do we determine this through code? Well, we can determine this by saying if the left side of our player right here, so obviously the left side of this blue rectangle, is less than or equal to the right side of our collision block, which is this right here, the two are definitely colliding from the left side of our player. Let's start by writing that out in code. So I need to get the left side of our player, which I can get with this dot position dot x. Position dot x is the same thing as the left side of our player. Now, if the left side of our player is less than or equal to the right side of the block we're currently looping over, then we know these are colliding from the player's left side. How do we get the right side of the block we're looping over? We can get that with the collision block, which we're currently grabbing, dot position dot x. This will give us the left side of our collision block, so it's going to give us this right here. But if we add on the width of this collision block, we're going to get the right side of it. So let's add on to collision block dot position dot x, collision block dot width. And with this, we are detecting for collision on the left side of our player and the right side of our collision block. But we need to make sure that we're detecting for collision on all sides of this collision block. So let's say hypothetically that our player was over here for whatever reason and we're colliding with that same collision block, but from the right side of our player. How do we determine within code that the two are indeed colliding? Well, we need to get the right side of our player and then also the left side of that collision block. If the right side of our player right here is greater than the left side of our collision block, we know they're colliding from that side as well. So we're going to add in an AND statement to this conditional. Looks like this. I can hit enter and write if the right side of my player, which I can get with this dot position dot x, plus our player's width, which is going to be this dot width, is greater than or equal to the left side of our collision block, which I can get with collision block dot position dot x, then we know we are indeed colliding with the left side of the collision block and the right side of our player. So we're taking into account both sides on the x-axis. That is exactly what we want to start. So to further detect for a collision, we also need to take into account the tops of these collision blocks. So in this case, I'm going to say that our player is up here and we are falling downwards. And now we are colliding with the top side of our collision block. In order to get this, we need to get the bottom side of our player and the top side of our collision block. So we already know the gist of this. We can add an AND statement and say we want to get the bottom of our player with this dot position dot y plus this dot height. If this value is greater than or equal to the top side of our collision block, which we can get with collision block dot position dot x, we know they're colliding from the bottom of our player and the top side of the block. Now finally, we need to take into account collisions on the top side of our player. So if we jumped really high, we might be colliding with the ceiling up here. So we need the top of our player and the bottom of a collision block. So we'll add an AND statement that gets the top of our player with this dot position dot y if this is less than or equal to the bottom side of our collision block, which is going to be collision block dot position dot y plus collision block dot height. We know they are indeed colliding from the player's top side. So once we take all sides into account, this is going to provide us very accurate collision detection. We know we're colliding with that in some way, no matter which side we're coming in from. So the collision check we just did checks for all sides of the rectangle, but we want to start with horizontal collisions first. So if we end up in this position right here, we're going to push our player over on the x-axis. How do we detect within this collision check that we're in a position like this? Well, simple enough. Within this if statement, I'm going to also check if this dot velocity on the x-axis is greater than or less than 1. So if it's less than 1, I know I'm moving over to the left. We are indeed colliding on the x-axis. We can comment that out, say collision on x-axis going to the left. And if there is indeed a collision on this x-axis, how do we want to respond to this event? Well, we want to take our player's position on the left side and move that left side to the collision block's right side. If we do that, we're going to put our player back over here and we're not going to be able to move past this point. So let's do that. So if our velocity on the x-axis is less than 1, we're going to take the left side of our player, which is this dot position dot x, and set it equal to the collision block dot position dot x plus collision block dot width, which will give us the right side of our player. But that might put us directly on the very edge of our collision block. So what I like doing is adding on a buffer right here, just something really small, like 0.01, to make sure that we're not still on top of that collision block, but that'll move our player back over to the right side of the block. Now I also want to do the same thing if we are moving to the right. So I'll add an if statement that says if this .velocity.x is greater than 1, I basically want to do the same thing that we did up here, but I'm going to put our player's position in a different location. So our player's position on the left side is going to be equal to what? Well, let's visualize this. If we're coming in from the right side over here, and we start colliding with a collision block we want to move the player's left side so that it's equal to the left side of our collision block minus our player's width. If we do that, we're going to push our player over to the left to the correct position. So this .position.x will be equal to the left side of the collision block, which we'll get with collision block .position.x, and then we want to subtract from this .width, so our player width. And I'm also going to subtract a small buffer, so we're not always colliding with that block right there. And whenever we detect some sort of collision with a block, I immediately want to break out of this for loop because it's inefficient to have to go through the whole thing. We already know we're colliding with one thing. Let's run this once and then go on to the next statement after this for loop. So we're going to break out right here if we're colliding with the left side of our player. We're also going to break out right here if we're colliding with the right side. But this should give us collision detection on the x-axis given everything was written correctly. So let's save this, refresh, and see if we can get this working. So I'm going to jump in from the left-hand side, and when I hit one of these blocks, we should not be able to go past it. So I jump, and you can see right there, no matter how hard I try to get past that block, I am just not able to. I can even jump past these, but when I try moving to the right, it's just going to push me all the way to one of the sides because we have all these collision blocks in the middle. And if we go test from the right-hand side, jump up into the left, well, it looks like it is not working. If it is not working for one of the sides, it just means we have some sort of bug, probably some sort of syntax error. So let's analyze this. I have no doubt it is within our collision statement. We want to be very precise with this to make sure our collision is always working. And if we look very closely, when we're referencing position.y, the top of our player, over here, we are referencing our x position on the collision block. Well, we don't want to detect from the bottom side of our player and the left side of our collision block for a collision. We want to detect from the bottom of our player and the top of our collision block, which in this case, we need to replace x with y. So we want to make sure that we're always referencing y within the same statement and x within the same statement. And I think with that, we should be okay. So let's refresh after saving that and go over to the right-hand side, jump towards the left, and there we go. Just that simple bug fixed everything. So now we have collision on the horizontal axis, which is absolutely great. What do we want to do now after this? Well, remember our checklist. The next thing we want to do is apply gravity, which we are doing with this down here. This is when we apply gravity to our formula. So we already have that taken care of, which is absolutely great. But the next thing we want to do down here is check for vertical collisions. Because as gravity is applied, well, we might be colliding with one of these bottom blocks down here, and if we're colliding, we want to push our player back up so it looks like they're standing on top of one of these blocks instead. So to check for vertical collisions, what we can do is copy this code we just wrote in which we're checking for horizontal collisions. I'm going to copy that whole thing, paste it down beneath our comment where we're checking for vertical collisions. I can get rid of this comment right here. We're going to do the exact same thing for the beginning. This collision detection code checks for all sides of our player. So we know that's great, but if we want to check for whether or not we're colliding on the y-axis, all we need to do is change this .velocity.x over to y in both locations, and then determine how we should react if we're colliding with the top or the bottom of our player. So if our player is going up, meaning our velocity on the y-axis is less than 1, we want to change our y position. What do we want to change our y position to? Well, let's visualize this. If we're colliding with the top of one of these collision blocks, we want to change it equal to our collision block position on the y-axis. It'll be that right here, plus our collision block height. If we add on our height, it's going to give us this location in which we can push our player down to. So let's get our collision block position on the y-axis, plus our collision block height, plus our little buffer right here of 0.01, and that should take into account collisions whenever the top of our player hits a collision block. Let's do the same thing for when the bottom of our player hits a block. We're going to change our player's position on the y-axis equal to the collision block's position, on the y-axis of course, minus our player's height instead. We also provide the buffer, and that should put us in the exact position we want. So let's save, refresh, and now you can see as soon as our player spawns, we're spawned on the very top of this. So to get our player spawning within our boundaries, let's change our player's position and also the width and height so that it's a lot smaller. I'm going to scroll up to where we're setting width and height, and change our player to have a width and a height of 25 instead. And then for our position, let's go ahead and say 200 by around 200 should be okay, I want to say. Refresh, and now you can see our player is pretty much in place, but what just happened right there? Why did we pass through our collision? Well, remember, we're always going to be adding gravity onto our player's y position. And as we apply gravity, we're going to be checking for a collision further and further down. So for one frame, we might be right here. Yes, we do have a collision, so we push ourselves back up. But for the next frame, our y velocity will be even greater because we just added more gravity onto that y velocity. So we might be all the way down here and push our player up. And eventually we're going to get to the point where we're pushed all the way down here. And if we're pushed all the way down here checking for a vertical collision, there is no collision until we hit the very bottom of our screen and hit that other conditional in which we're detecting for a collision at the very bottom of our canvas. So whenever we have a collision, especially on the y-axis, we want to make sure that we're resetting our y velocity equal to 0. That way we're not just adding a greater and greater value onto it until our player goes past one of our collision blocks. So let's go ahead and do that now. We're going to go back to our collision code, specifically on the y-axis. And I know this is dealing with the y-axis, so I can get rid of this comment referring to the x-axis there. But whenever we have a collision and our velocity is less than 1, meaning we're going up, we want to set this .velocity.y equal to 0. Same thing if our velocity.y is greater than 1. We're going to reset that back to 0. And that should solve the issue with our player going past one of our collision blocks. So let's save and see what this looks like. We refresh, and we fall, and the collision detection is working, but we have this jittery effect where our player is just bouncing up and down. So we just have to inspect our code further, make sure we didn't do anything wrong. If we look closely, well, I'm a big dummy, and of course our velocity.y can be less than 0 to -1, so it could be like a value like 0.5, and we're not checking for that. So if we're going up, we also need to make sure that we're checking for those values by saying if our velocity y is less than 0, so something like -0.5, then we respond in this particular way. So we don't want to check whether or not y is greater than 1 here either. And also in the horizontal collision, we want to change the 1 to 0. Sorry about that. It's a small mistake on my part, but it happens. So let's save that, refresh, and see how things look. So looking really good. We can move to left and right, and our collision detection works on that axis. Perfect. But if I hit W, still we're having an issue. We're not jumping up or down. So the issue here is we're running through our vertical collision detection, but we have this old code detecting for a collision at the bottom of our canvas. And really, if we look at this, this is actually where we're applying gravity to our velocity. So we want to take this line right here, cut it out, go up to where we're applying gravity, and paste this as the very first thing before we apply our velocity to our player's y position. We no longer need this .sides.bottom, unless we really want to detect for the bottom of our canvas, but it doesn't really make sense because we're always going to be putting our player in the center of these blocks, and we can get rid of this entire if statement and also the comment right here. So as long as we're moving our gravity to where we're actually applying the gravity in this exact location, save and refresh, once we hit W, we should be able to jump up. And with this, our collision detection is working on the top of our player, and we can even increase this jump velocity by going inside of event listeners and making sure we're decreasing this to something lower, so like 25. Can save that. And now we're definitely hitting the top and responding in the correct manner. And this is going to work for every single collision block we have on here, on every single axis in which our player moves. So that is how we're going to add collision detection between our player and all the blocks on the screen. But we're not done just yet. I want to make sure that I'm refactoring our code over in player.js to make sure that this is as readable as possible. So to make this as readable as possible, basically all this code in which we just wrote, I want to put them within their own separate functions, so I know exactly what is happening within update, rather than trying to determine what's happening by looking at all this code right here. So let's start with checking for horizontal collisions. I'll take our entire for loop, which does that, and say instead I'm going to call this .check for horizontal collisions, like so. And if I want to use this method, I need to create it. So where does update end? It's going to be right here. Now I can go ahead and call check for horizontal collisions. And inside of this, I'm going to paste all that code in which we just wrote. We always want to make sure that we're saving and refreshing to make sure everything still works. And indeed it does. But now this is a little cleaner within update. We don't even need this comment now. Let's do the same thing for applying gravity. I'll take these two lines right here, and then instead call this .apply gravity. So now I need to create that method, which I can do down below by calling apply gravity, and then putting in those two lines. So now this is available to us. I can call it up above. I no longer need this comment. We'll do the same thing for checking for vertical collisions. So I'll go to the very end of this for loop right here, and then replace that with this .check for vertical collisions. And now I just need to create this method. Doesn't matter really where I put it, but to keep things consistent with the order we should be calling this in, I'll do it right after apply gravity and check for vertical collisions. Paste that on in, and now I can get rid of this comment. This is a lot more legible to me in regards to what update does compared to just putting everything directly in there. So let's save, give it a refresh, jump around a bit, and everything still works as expected. So now we're going to be able to go back to to-do, successfully check off collision detection. Next, we're going to add sprite animation. So we're going to change our player, which is currently a red square, into an actual image that has animation associated with it. So to start, if we look within our image directory, we're going to have a directory called king. And within this are going to be all the different versions of our main player. This is one where we enter a door. This is one when our player is standing idle. And right here is where we're running to either the left or to the right. So we're going to be swapping in between these, but we want to start off by creating our player with this sprite sheet right here. So we know this is within our project because we already added all of our images. But for our player to use an image, I no longer want them to call just c.fillStyle and c.fillRect. I actually want to use the Sprite draw method instead. So we're going to extend our player class right here. And we can do that by adding on after player, extends, and then Sprite. So we're going to inherit from our Sprite class that is going to be the parent. And if we want to make use of the Sprite class's draw method, we just need to get rid of our own draw method down below. And it's as simple as that. Now when we call draw, we're going to be calling the draw method associated with Sprite instead. But if we look within Sprite.js, in order for draw to work, well, what properties do we need here? We need to make sure that we have image source because we want to pass that through into the image that is actually used within c.drawImage. So over in player.js, we also need to make sure that when we create a new player, that we're passing through an image source. And then to pass this on through to the Sprite constructor up above, we can call super, which is just going to call Sprite's constructor. And within this object right here, I'll pass through our image source. So basically when we create a player, we're going to pass through an image source. We're going to pass through the image source into our Sprite's constructor. And that in return is going to set all the properties that we have within Sprite.js, including this .image, which will allow us in return to use it within this draw method right here. So for adding image source to our player class, we need to make sure that we're actually passing this through whenever we create a player. So we'll go to index.js, and we know we're creating a player right here on line 18. So we're not only going to pass through collision blocks, but also an image source. What is the source of the image we want to use to create our player image? Well, we know we need to go inside of our image folder. So we'll go inside of img/king, because all of our player image sprites are within there. And then within king, we want to reference idle.png. So /idle.png. So let's save, refresh, and see what this looks like. So on refresh, we now have our player being rendered out with some images. But as you can see, we are using the full sprite sheet here from the very beginning to the very end. We want to crop this sprite sheet so that we're only using one of these images at a time. And this is how animation is going to work. If we crop this entire sprite sheet so we only show this one image right here, we can then begin to move this crop mark to the very next iteration of the sprite sheet. And if we begin moving this crop mark really quickly to where we're only showing each version of the image at a particular point in time, we're going to give off the illusion as if our character right here is actually moving. So this is the exact logic we're about to code. Is we're going to crop our image, and then we're going to basically begin shifting this crop box to each other image within the sprite sheet. And by doing so, we're going to create animation. Now, before we begin creating that animation, why is our image right here going past our collision blocks but stopping near the bottom? Well, to figure this out, we're going to actually render out where our player collision block is at this point in time so we can see where exactly we're stopping. To do this, we're going to go on over to player.js. And within update, I'm going to call c.fillStyle, set this equal to, let's just say blue, and then I want to call c.fillRect. And I'm just going to draw a rectangle at this.position.x, this.position.y, using the width and height associated with our player class. So this.height for the fourth argument. So let's save this, refresh, and see what happens. So right now, really we're detecting for collision based on the width and height of this rectangle right here. This is actually our player, but we're just rendering this image next to where our player is actually located. Instead, what we want to do is extend the width and height of our player right here to take up the full width and height of just one frame of this actual sprite sheet image. So since player inherits from sprite, we're no longer going to use some set width and height values like we're doing right here. We can get rid of these two and go over to sprite.js, and inside of here is where we're going to set those width and height properties. So those are going to be dependent on the image we're currently using. So if we want the width of our player to be the full width of our image, we're going to say that this.width should be equal to this.image.width only when the image fully loads. If the image does not fully load, this will not be available to us, therefore width will not be set. So we need to make sure that we're doing this right here. And then we want to set our height equal to this.image.height. So now that we removed width and height from our player class over here, it's going to inherit this width and height property from the Sprite class instead. So let's save that, refresh, and now you can see that we are drawing in the full width and height of our sprite sheet, but it is so large that our player by default is just standing on top of our entire map. Remember what I said, we only want the width of our collision to be one frame of the sprite sheet, not the full width. So to determine the width in which our sprite should actually be, we need to look at how many frames it consists of. So I'm going to click on idle.png, that's what we're using, and count out the frames. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 frames long. So we're going to remember that, and within sprite.js, whenever our image loads, we're going to divide this .image.width by that frame count, which in this case is going to be 11. So let's keep that in the back of our minds. For now, we're going to make this dynamic later, but 11 in this case is our frame count. Let's divide that, save and refresh. And now you can see our collision block is only taking up one frame. This is still a little too large. We're going to want to use a hitbox that only takes up the exact area of our player, but we'll do that later in one of the following lessons. But now you can see at least we fit within the bounds, and we can jump around, and this new collision block works as expected, which is really cool. But with this new collision block, we're going to want to start animating our sprite sheet so that this guy right here begins moving over to this location. And as long as we do that correctly, we're going to give off the illusion of animation. So I'm going to give our blue rectangle over here some opacity so we can keep it in there but still see everything going on in the background. We declare that within player.js, and right here within c.fillStyle, I'll replace blue with RGBA. Declare I want red to be 0, green to be 0, and blue to be 255, the full value. And I want this to be 0.5 for the alpha value, which is going to give it some transparency. So save, refresh, and now we can see our player. So we want to animate this guy to this location. How do we do it? Well, the first thing we're going to do is crop our sprite sheet so that we're only showing our first frame. So this guy right here. Let's go over to sprite.js, and to crop our sprite sheet, we're going to use basically an enhanced version of c.drawImage. Instead of using just 3 arguments right here, we're going to have to use 9. Not the best function design, it's kind of old, but this is the way we do it within Canvas. So the first argument is going to remain the same. It's going to be the image we want to use, but the next 4 arguments, arguments 2 through 5, are going to be the dimensions for the crop box in which we want to crop our image to. So right above this, I'm going to create a const called crop box. That can be a capital B or lowercase b, whichever you'd like to use. And a crop box is going to have a position, which has an x and a y. So x I'm going to start at 0, y I'm going to start at 0, and then we're also going to have a width and a height. So our crop box width, what should that be by default? Well, I'm going to make it this dot width because we know this dot width is our image width divided by the frame count, which is going to be the exact width in which we actually want to crop our crop box to. So width will be equal to this dot width, and then our height will be equal to this dot height. That's actually going to remain the same. We don't need to divide that or anything. And just make sure you don't use a period like me and use a colon, and we should be good to go. So now that we have this crop box const, we can begin using it within c.drawImage. So as I mentioned, arguments 2 through 5 are going to be the crop location. So argument 2 will be the x position, which we can get with crop box.position.x. The third argument is going to be the y position, which we can get with crop box.position.y. The next one is going to be the width of the crop box. So crop box.width, and then finally it's going to be crop box.height. And then add in a comma right there. So this is what c.drawImage is going to look like to start. The next 2 arguments are indeed going to be this .positionX and this .position.y. This is the position of where we actually want the image rendered out. And then finally, we want to declare the actual width and height of the image. We can just use the ones that we already assigned to this .width and height. So we'll put in this .width and then this .height. So as you can see, we have 9 arguments, a big function, but this is what we need to begin cropping our image. So let's save this, refresh, and you can see, well, we definitely cropped our image, but what else did we crop? We cropped our whole entire background image as well. We do not want to crop that, but why is it being cropped in the first place? Well, remember, our image also uses this sprite class. We need to make sure that we're taking that into account and that we're not dividing our image width for our background by 11, because our background image only has 1 frame. We should not be dividing it by 11, or else we're only going to get 1/11th of the actual background. So this number right here, 11, needs to be dynamic. And to make it dynamic, we're going to add in a property called this .framerate. It's equal to the amount of frames within an actual sprite sheet. And since this is dynamic, we need to make sure that we're passing it through as an argument within our constructor. So I'm going to add it right here, copy this, and then add it as an argument. And now I know that I can use this within .onload. So I'll add in this dot frame rate right here. And one more thing I want to do is assign frame rate a default. So if no frame rate is passed through, I want to set frame rate equal to 1, meaning there's only one frame in which we can render out, such as our background image. And this should take care of things, at least for the background image. But we do need to pass through a frame rate for our new player image sprite. So let's find out where we're creating our player. It's going to be in index.js. And when we create a player, we want to pass through a frame rate with a capital R like so. And we know that's going to be equal to 11 because there are 11 frames within idle.png. But if we save this, refresh, things just don't work. And a big reason for that is within player.js, we never actually passed through that new frame rate property. So we're creating a new player. We need to pass through a frame rate. And then we need to pass frame rate through our parent class's constructor. So we'll pass it through right here as a second property. Let's save, refresh, and now our player is back. And that's honestly a great start. But where's our background image at? Well, let's check within sprite.js. It looks like up here on my tab, I have an indicator that I have not saved this file when I set frame rate equal to 1. So let me save that, refresh, and there is our background image back in place. So we just want to make sure if we're creating a sprite and where we're not passing through a frame rate property, that we at least have this set equal to that default 1 value, and it should render out that image without us having to do any extra work. So we can jump around, move around as needed, but we do want to create some sort of idle animation associated with this crop box. So we completed step 1, where we created the crop box, but now we want to move this crop box periodically to wherever the next frame is. And as long as we're only moving the crop box and we're keeping the image position in place, it's going to give off the illusion of an animation. So how do we begin moving that crop box? Well, we want to change this right here, our crop box position on the x-axis. So we know this right here needs to be dynamic, and it needs to be dependent on the cropped width, which we have right here assigned equal to this dot width. So I'm going to grab this dot width, and then I want to multiply this by this dot current frame. So what is the current frame we're on within our sprite sheet? By default, this is always going to be equal to 0 actually. So this dot current frame is equal to 0. If we save this, refresh, we're going to see the exact same thing, which is great actually. But now we can begin iterating current frame upwards until we hit a frame of 11. Once we hit a frame of 11, we're going to go back to this 0 value. It's basically going to allow us to keep shifting through our sprite sheet because we're increasing our crop box position on the x-axis by the crop width times that new current frame. So this is just going to keep increasing until we tell it to go back to the beginning. And as long as we're telling it to go back to the beginning, we're going to create an animation loop. So to start increasing this value, we need to increase this .current frame. And I want to do this within some sort of update function, but something different from a name of actual update because I know I'm already using that within player. And I know that it will overwrite the parent update if we were to write it out like this. So instead of just calling this update, I'm going to call this update frames. That's more descriptive anyways. And within update frames, I'm going to take this .current frame and add 1 onto it for each frame we loop through. But in order for this to activate, I need to make sure that I'm adding in to our draw method right here. So we're going to load up the first frame, and then once we go through this whole thing, we're going to call this .update frames, which will launch us into the next frame for our animation. So if I save this, refresh, you're going to see a very slight animation, but it's way too fast for us to even really comprehend. So we're reaching the end of our sprite sheet, and once we reach the end, we're just going to keep pushing that crop mark off to the side, and if that's pushed so far off to the side, we're not rendering anything in the first place, which is why we don't see anything for our player anymore. So we want to say if this .current frame is less than this .frame rate, the max amount of frames associated with the sprite sheet, minus 1 because we're starting current frame at 0. Only then do we want to start adding 1 on the current frame. Else we know that we've reached the max frame rate, so we should set this .current frame back equal to 0. We're going to go back to the very beginning. So we save this and refresh. You can see we have an animation in place. This is what our sprite sheet animation looks like, although it is quite fast, way faster than it needs to be. So we need to reduce the frames per second in which this animation is running. And to do that, I'm going to add in 2 more properties within our sprite constructor. The first one is going to be this .elapsed frames, and it's going to be equal to 0. And then I'm going to add in another called this .frame buffer. And this is going to be equal to, let's just start off with 2. So here's what we're going to do is we're going to keep increasing elapsed frames over time. And if elapsed frames is divisible by our frame buffer, only then are we going to increase our current frame, which puts us into the next version of our animation. So let's write that out. If this .elapsed frames is divisible by this .frame buffer, And to say that this is truly divisible, we need to set this equal to 0. This is the modulo right here, which gets the remainder of this division. So if that remainder is equal to 0, we know it's divisible. Then we can call this if statement, which actually increases our current frame. Now we can definitely get rid of this up here. We don't want to be increasing current frame for every version of update frames. It should really only happen in this if statement anyways. And instead of increasing that, we're going to increase this .elapsed frames instead. We're always going to be adding 1 onto that to make sure we're always checking for whether or not elapsed frames is divisible by this .frame buffer. So let's save that, refresh, and now you can see that is much, much smoother for animation. So let's comment out this blue box for now, just so we can see the full thing. Go to player.js, comment out the blue box. I'll actually add a comment that says, this is the blue box for later reference. Save and refresh, and that is looking really, really cool for our animation. So that's what it takes to start animating stuff within Canvas and using a sprite sheet. It's going to allow us to go back to To-Do and check off sprite animation. So next up, we're going to add in a hitbox implementation. So what is a hitbox? Well, right here, our player is obviously not touching the ground. I want to make sure that our player falls down and their feet are touching these collision blocks. So how do we go about that? Well, right now, our player is rendered out like this. We just have one large frame, and we have some space around it so that we can add in things like attacks later on and still show them in the visible area. But if we want to change the position of our actual player, we need to add in a hitbox, which is just going to be a little box around the exact area in which we want our player to start colliding with collision blocks. So we need to add this in, and then we need to alter our collision detection to make sure that we're monitoring for just this right here instead of our outer box. And when we do that, we're going to allow our player to fall down, move around, and then be controlled by just this box right here. So how do we go about doing that? Well, let's head on over to player.js. We're going to go inside of our update method right here. Now I'm going to start off with monitoring for collision detections with this new hitbox. So right before that, I'm going to create something called this .hitbox and set that equal to an object. Now, where should our hitbox be located? I want it to be located relative to wherever a player is currently positioned. So I can say I want a position property on this hitbox and set an x equal to this .position.x, wherever a player is on the screen. I want to do the same thing for y, to say the y position should be this .position.y. And this is obviously going to have a width and a height. That's what we're going to use to help determine these collisions. So we want to add in a width. And I only want this to cover the width of our actual player sprite. So about 50 pixels, I believe, would be a good start. And then same thing for height. Let's just start off with a box and say our height's going to be 50 pixels as well. So if I were to save this and refresh, we're not going to see anything because we're not rendering anything out. If we want to render out this hitbox so we can get a visual indicator of what this looks like, we want to call a c.fillRect method. It's going to take an x position, which we can get with this .hitbox.position.x. Same thing for y, we want to reference this .hitbox.position.y. And then also we're going to grab this .hitbox.width. And then finally we need to add in the height as well. So this .hitbox.height. And with this we should be able to see this hitbox being rendered out on top of our player. So let's save and refresh, and there is our hitbox. So we're starting off where our main player sprite is being rendered, and like I said, it's going to be contained within this larger box up here, so it really starts from right about there. But we want to move this hitbox over by this offset and make sure that it covers our player where this other blue box is. And that's going to determine where we start colliding with stuff. So we just need to add in some offset to our hitbox, and I'm going to do that by adding on a value of, let's just say, 50 to start to our x-axis. I'll say something like 30 for our y-axis, and let's just see what that looks like. Save and refresh, and that's pretty close. Looks like we want about 5 more pixels, maybe 10 on the x, and we just kind of have to eye this to make sure that we get it right over our player. And I would say maybe about 3 more, so let's go to 58. And I like how that looks. So I do want to push things down on our y-axis because this is a little high up and our feet are still showing down there. So let's push this down by adding onto y about 4 pixels. That's looking good, and then we want about 3 pixels on the bottom to cover the feet. So I'll add on to height around 3. And I think that is a really good start for where our collision box should be. So now that we have this collision box object, we need to use this to monitor for collision instead of that main large outer box. And to do that, we're going to start by looking at check for vertical collisions. So let's scroll on down there, and here it is. So this is where we are detecting for where a collision exists, and we're currently using that main large box. We want to use our hitbox now instead. So any place where we have this .position x, this .position y, this .width, this .height, and so forth, we want to replace that with this .hitbox instead. So let's do that. I'm going to select all 6 of these using Sublime Text, Command D, and then I'm going to change this with this dot hitbox dot position x position y width and height. And with this, if we give this a save and refresh, you're going to see we're monitoring for collision with our hitbox. But the issue is when our hitbox hits one of these collision blocks, well, we're moving our player too far up now, because prior we were moving our player up based on the height of our main larger box. Now we have to move our player up based on the height of the collision box, but also the large box. It's a little confusing to think about, but we're going to go ahead and visualize it. So let's go over here, and I'm actually going to revert that code so this guy isn't jumping up and down and annoying us while we try to focus on something. We're just going to stay right there, and then I'll go back to where we were without saving and refreshing. Remember, this box right here is dependent on the position of this larger box. So our larger box is going to be moving down, and this is going to be moving down as well. So eventually, this box right here, our hitbox, is going to start colliding with one of these collision boxes. And once that happens, we're saying, well, move this up by the full height of our larger box right here. If we move this up by the full height, well, we go up to this position, which means that we have this little gap at the bottom, which we can still fall down with our main hitbox. And that's why we're getting that up and down jump effect right there. So what we want to do instead is when our main box goes down here, and then our hitbox collides with one of these collision blocks, we only want to move our main box up by the distance between the bottom of our hitbox and the top of our main large outer box. So when we're colliding, if we only move up by that amount, it should be right about here. Since we're only detecting for a collision with our hitbox, we're going to be placed right on top of the ground. And that's exactly what we want. We can ignore the position of our outer box because now we're only detecting for a collision with the bottom of our inner box. So how do we get this distance right here? How do we say move our player up by this green line distance instead of the distance of our entire outer box? Well, really, we're going to need the top of our hitbox, so this right here. And if we subtract from the top of our hitbox the top of our main outer box, we're going to get this length. That's going to be a start, but if we add onto this also the height of our hitbox, well, we're going to get the exact length of this green line in which we need to move things up by. So that's how we're going to do it, is get the Y position of our hitbox, subtract from it the Y position of our outer box, and then add on to that the height of our hitbox. So let's do that. Right here, this is going to be on line 103 when our velocity Y is greater than 0, meaning we're falling down. I'm going to create a constant side of this called offset. And offset is going to represent the length of this green line right here. So how do we get the length of that green line? Well, like I mentioned, we want to get this dot hitbox dot position dot Y. And then we want to subtract from this dot position dot Y. With this, now we have the top blue line right here. Now all we need to do is add on this dot hitbox dot height, and we're going to get the full length of this green line. Perfect. So now that we have the full length of the green line, we're going to take our collision blocks position dot Y. That is going to be the bottom of one of the collision blocks, and subtract from it not the full height of our blue outer box, but rather we're just going to subtract the offset instead. The exact amount of height we want to go up by, the green line. So let's save, refresh, and you can see that is immediately fixed. Great. So we want to do the same thing, but for when we hit the top of this, you can see there's a little jitter right there. We want to make sure that we're pushing our player down by the exact amount required, rather than having to calculate those collisions based on the main outer blue box. So how do we go about that? Well, in this case, we only need the distance between the top of our hitbox and the top of our outer box, and we already know how to get that. We just take the top of our hitbox and subtract from it the top of the outer box. So let's go inside where we're going upwards right here. I'm going to create a const called offset, and then this is going to be equal to this dot hitbox dot position dot Y, and subtract from this dot position dot Y. That's going to give us the amount in which we need to shift our player down by. So we're going to take our collision block dot position dot Y plus our collision block dot height, that is the bottom of the collision block, and then subtract from this our offset. So that little amount that was on the top between our inner box and our outer box. So we save that, jump, and you can see that is just much better. We're not getting pushed around as much, and once we get rid of this red box, it's going to be even more apparent. But now you'll notice if I try hitting A or D, we're just kind of shifted around. Why is that? Well, to understand this, we need to look up above within, check for horizontal collisions. And you can see within here, we're still detecting for a collision based on the X and Y coordinate of our main outer box. We want this to be focused in on our new hitbox, the inner box. So where we're detecting for a collision here, we also want to reference this dot hitbox dot position dot X and Y, width and height, instead of the main outer box. And when we do that, save and refresh, well, things seem even more broken. Now, why would that be? Well, we're using this dot hitbox right here, but if we scroll up above, we're only defining this dot hitbox right before we check for vertical collisions. So one thing we need to do is we need to make sure that we're assigning this dot hitbox before we check for horizontal collisions as well. We need to do this right here and also right before we check for horizontal collisions, because after we check for horizontal and vertical collisions, we are altering the position of both our x and y coordinate. And if this.hitbox uses this.position x and this.position y, we need to make sure that we're updating this.hitbox after each calculation. So it's very important that we call this in two locations. Now we could call it right here and right before this.check for horizontal collisions, but this is a little messy and we can clean this up using a method. So let's create a method called update hitbox. And inside of this, we're just going to paste in this.hitbox is equal to this object that is dependent on this.position.x and this.position.y. So once we do that, we can get rid of this.hitbox in these two locations, which we'll do, and then replace this with this.update hitbox instead. So I'll grab this and then also replace that up here. And now that we're updating our hitbox before we check for both horizontal and vertical collisions, we should be in better shape. Let's save and refresh, and yeah, that seems to be a lot better. And we can even move around, and everything is still working as expected, but now we're focusing on just this hitbox for collision rather than that main large outer box. But watch what happens. We still need to alter things for when we're checking for X collisions. If I move to the left and run into this collision block right here, you're going to see that we're just moved over by the wrong amount. And same thing is going to go if I go over here. We're just moved over by the wrong amount. So let's focus on check for horizontal collisions. And we know when we're going to the left that we need to move our player over by a certain amount, and it's not going to be completely dependent on just the collision block.position.x and collision block.width. We kind of need to do the same thing that we did for the y-axis. So let's get that little amount of space on the x-axis between our large outer box and our player's hitbox. We can get that by creating a const called offset, and then we're going to grab this .hitbox.position.x and subtract from it this .position.x. And as long as we have this, we can subtract from the right side of our collision block, which is calculated with these two right here. Let's subtract from this our offset. It's going to make sure that we're placed in the correct position on the x-axis when we're moving over to the left. So now when we try moving to the left, we no longer get transported back over to the right, and there's no jittery effect. But that still will happen if we go to the right. We need to take that into account as well. So if we want to speed this up a bit, we can go down where we check for vertical collisions, and we can find the code in which we wrote to get the correct amount of spacing when we are going downwards. And it's going to be right here where we're assigning offset equal to these three. So I'm going to copy this, scroll on up, and now when our velocity on the x-axis is greater than 0, I'm going to reference an offset right here. And instead of referencing my position on the y-axis, I'm going to replace this with x right here, and then I want to reference our hitbox width instead of height. And as long as I do that, offset should be calculated correctly. So now I know when I'm going to the right, I want to take our collision block.position.x, which is the left side of our collision block, and subtract from it not this .width, but rather our offset. That's going to give us the correct amount of spacing in which we need so that we're not jumping back and forth. So we can save, refresh, and now when we go to the right, that is no longer happening where we're teleporting over back to the left. So this is perfect collision detection, but using this new hitbox feature. And I can't really get a bug using this. I haven't experienced it yet. So I think this is a pretty good transition over into the next lesson. So let's comment out the visual hitbox, and we can do that by heading on up to update. Right here where we're filling in a rect, I'll comment this out. Save, refresh, and now we have some really good collision detection going on between our hitbox, sprite, and all of the collision blocks around us. So cool. Let's head on over to To-Do and check off hitbox implementation. Next up, we're going to work on sprite swapping, so making sure that when we're running over to the right, we add in a running animation rather than just keeping this idle animation. Once we add this in, it's going to make our game look much more realistic, so it's very important that we actually put this in there. So how do we even begin this? Well, I think what I'm going to do is go over to index.js and then start within where we're creating a new player. What I'm going to do is add in an animations property. This is going to be equal to an object. Within here, I'm going to define all the animations I want to add in to our actual player sprite. So let's start off with what we have. We have an idle animation in which our player is currently facing the right. So I'll add that in by saying idle right is going to be equal to an object. And we can even look up above for reference in regards to what data property should be going in this idle right animation. So we need a frame rate of 11. We already know that exists. And then I believe our frame buffer was equal to 12. And I think we also have loop in there set to true. And that kind of defines what our animation is currently. Now this animations object is going to act as our library of sprites that we can switch between for this one individual sprite we're working with. So our player sprite is going to have a library of multiple animations. Let's go ahead and copy this, paste one down below, and then replace idle right with idle left. This is going to have the exact same data down below, but if we look within our king folder, we have run left and run right as well. We want to add these in here too. So all I need to do is copy these two objects, paste them down below, and then replace idle with run. So we have run right and run left, but we do need to change the frame rate and possibly the buffer for these as well. We'll experiment to see what the buffer is going to be, but we can get the frame rate right now. Let's look at run left and see how many frames this is. It's 1, 2, 3, 4, 5, 6, 7, 8. So that's how many frames we need to go through before we go back to the beginning. So we'll declare within index.js for run right and run left that we have a frame rate of 8 in both of these locations. And that's really all we need to get started. So we're passing through this animations property right here. We need to declare that this is something we know we're going to pass through with both our sprite class and also our player class, because I want to make sure this is available to us in case we want to use it in another generic sprite. So we need to make sure we do it for both. So over in sprite.js, I can declare at the top within our constructor, I want to pass through an animations property. And down here, I'll create that property with this.animations and assign it to the animations argument. That's all we need to do to start, but we need to do the same thing for player as well. So I'll scroll up. So we want to pass through an animations argument possibly. And then I already know that's being assigned within our parent, so I can add into super animations. We're going to get the exact same effect for our player class too, which is great. But let's go on over to sprite.js and review what's going to happen. So whenever I press down on one of these keys right here, I want to switch on over to a new sprite. And to switch on over to a new sprite, I need to change whatever this.image is equal to. I need to set it equal to a completely new image object that's associated with whatever animation we want to show on the screen. So for each of the animations in which we just passed through in index.js, these four right here, I need to create a new image object associated with each of these. Now, how do we do this in a way where we don't have to keep typing out new image.source is equal to this? Well, the way I do it is right after I assign this.animations equal to animations, I can say if this.animations exists, so we know that we're going to have multiple within this one object, then I want to run a for loop through all the keys available to us within this object. So I can do that with for let key in this.animations. And what this is going to do is loop through all the keys associated with the objects within this.animations. So we're going to reference idle right, then we're going to go to idle left, we're going to go to run right, and then we're going to get to run left. But we're only going to get the keys, which means we're not going to get any of this data inside of these actual objects. We're just going to get the name of the object. So things like idle right, things like idle left, things like run right, and so forth. That's basically how this for loop is working. So as we loop through each key, I'm going to create a const called image and set this equal to a new image object. Now that I have this new image, I can say for this loop, assign the image.src, the image source, equal to image source available to us within the current object we're looping over, which we can get by referencing this.animations. This is going to make all the objects available to us, and if we wanted to grab just one individual object, particularly the one we're looping over, we would add in some brackets like this, and then use the key in which we want to reference that object. So for the first iteration of this loop, we're basically grabbing idle right and all the properties inside of it. So what property do we want to reference? We want to reference .image src because that is what we wanted to assign to an image.source. But you may have noticed over in index.js, we never actually passed that through. That's the property that we missed when assigning these originally. So what is the image associated with idle right? Well, it's going to be the same image in which we're using right here for our default. We can just grab this and paste it in within idle right. Now let's go to idle left, paste in the same thing, but we want to reference a different image for when we're looking to the left and idling. And we have the image right here. It's going to be idle left.png. So we can just reference that by going inside of image, king, and then idle left. Now we want to do the same thing for run right and run left. So let's reference those images. Here for run right, we're going to reference run right.png, which is right there. And then same thing for run left. We're going to reference run left.png, which is also right there. So now all of these are available to us, and we can use them within sprite.js to assign our image object an actual source. So that's the first thing we want to do. And now we just want to make sure within each animation object in which we have that we're assigning the actual image we're creating equal to a property called .image. So we're going to take that one object and assign to an image property the image in which we created. So really what this is doing is it's automatically creating an image property like so with new image, with source already assigned to us, but we need 2 lines to do this, and so we're just running it through a loop and assigning this image to each of our objects automatically. Just a quick little way to make things go a bit quicker. So let's get rid of this. And then at the end of this for loop, I'm just going to console log out this.animations to make sure that this was populated correctly. So let's save, refresh, everything's still working. We go over to inspect element, I'm going to extend this out, go over to console, and open up this object. So you can see we have idle left, and if I look in there, we have an image object, which is exactly what we wanted. An image source should be assigned correctly to that image, and this is going to work for pretty much every animation that we have inside of here. So run left has image, run right has image, and so forth. So now we can begin assigning our main render image right here to those new images we just created based on which keys we're pressing. So I'll get rid of this console log, and then I'm going to go to index.js. And I want to go down to our animate loop. This is where I'm going to start switching our sprite. So if our D key is pressed, we're going to be moving to the right, but I want to add more code in here, so I have to add these curly brackets. And when we move to the right, I also want our player to switch their sprite. Now, what sprite do I want to switch to? Well, simple enough, when I'm running to the right, I want to switch to the run right sprite. Now, this method is not currently available to us, which just means we need to create it. So let's save right here and go over to player.js and create a new method. I'm going to do this below update called switch sprite. Now we know switch sprite takes an argument. It's going to be the name of the sprite we want to switch to, but how do we actually assign this new animation image to the image that our sprite is currently using? Well, we can get the image our sprite is currently using with this .image, simple enough, and then we just need to assign it to this .animations, add some brackets, and then get the name of the actual image, which we're passing through right here. And we want to make sure that we're grabbing the image property associated with this animation object, which we can get with .image. So now we want to make sure that we're getting all the other properties as well, things such as our frame rate, frame buffer. Each of these animations might have a different version of those, so we need to make sure that we're reassigning it right here. Let's do that now. So I want to say this .frame rate. We'll select the animation which we want to switch on over to with this .animations name, and then make sure that we're grabbing the frame rate associated with that one animation. Let's do the same thing for frame buffer, and to expedite this process, we can hit Command-C, Command-V, and then in both of these locations, swap out frame rate with frame buffer instead. Now, whenever I switch on over to a new animation, I also want to make sure that I'm setting this .current frame equal to 0 so that we start at the very beginning of this animation, because our idle animation only has 11 frames while our running animation has 8. What if we're on frame 10 within our idle animation and we decide to switch on over to our running animation? Well, then we'd be rendering out frame 10. Frame 10 doesn't exist on the running animation. So before we do any of this, we want to assign this .current frame equal to 0. And with this, we should be good with switching on over to our running sprite. So let's save this, refresh, and now when we hit D, we should see some sort of running animation. And there's something going on there. It's not really animating until we stop moving, which is weird. Why is that happening in the first place? Well, when we hit D, what are we doing? We're setting current frame equal to 0 for every time we call switch sprite. And whenever D is pressed, well, we're calling switch sprite. We want to make sure we're only switching on over to this sprite if the current sprite we're on has not already been set. And we can do that by calling a conditional with if this.image is equal to the current image in which we're trying to switch on over to. Then we want to return. We don't want to call any of this code because we know these two are the same. There's no point of trying to switch to the same image and resetting our current frame equal to 0. Let's save and refresh and start moving to the right. And now we have a nice running animation in place. Now this might be a little too fast for you, and if you want to slow this down a bit, over in index.js, we just need to find where we declared run right, and then add on to our frame buffer. So let's just add on 4 instead of 2 for both run right and run left. Save and refresh. And now that's a bit slower, but also I think that matches a bit better. It's kind of fast before. I like the way this looks. So you might notice when we're running to the right and we stop, we still have that running animation in place. We need to switch back on over to our idle animation. So down here within our animation loop, if our D key is pressed, we're running to the right. If our A key is pressed, we're going to run to the left. Else, I want to switch our sprite on our player over to idle right. Because if I'm not doing one of these, I should just be standing around. So save and refresh, run to the right and stop. And now we go back to our idle animation, and we're starting to switch between the two. But we do need to add in animations for when we're moving to the left. So let's start off when we're pressing down our A key. We're going to add in more lines here, so we'll add in 2 curly brackets. All I need to do is copy player.switchSprite, run right, paste it into this else if, and then reference run left instead. It's going to be that easy. So let's save, refresh, run to the right, and then run to the left. Now we have a running animation for when we go to the left. When we stop, well, we turn back to the right. That's really the last thing we need to fix is when we run to the right and let go, we need to make sure we're facing to the left because that makes more sense, of course. So we're going to reference this else statement and add more lines inside of here. Basically, if we're standing around, I want to check for our last direction. So if our player's last direction was equal to the left, then I want to call player.switch sprite idle left instead. So idle left. Else, then we can call idle right. We know that the only other direction there is going to be right. We should be facing the right. But we don't have player.last direction set, so what we can do is grab this, and then whenever we press A, we can set player.last direction equal to left, and then when we hit D, we'll set our last direction equal to right. And that's really all we need to do. So let's save, refresh, we run to the right, stop, things look good. We run to the left, stop, and then we're facing the left. And now we have some really nice animations going on here with our player and all these different directions that we can go through. So this is all we're going to do for sprite switching, but you can really add in so much more with jump animations, attack animations, and so forth. Maybe we'll cover that in a future video, but this is a great start for idling and running in both directions. So let's head on over to To-Do, and we're going to check off sprite swapping. So now to go to another level, we need to enter a door and then activate the necessary steps to change our level. But the first thing we need to do is actually populate our map with doors so that we can enter them. We're going to have to animate these as well. So where would I start with this? Well, I know I want a door somewhere over here so that we're forced to kind of traverse this map, get to the end, and enter a new portion of our actual map. So if we look over in our game, in our image folder, we have something called door_open.png. And this is the animation we're going to use to open and then enter a door. So we want to pull this into our game first. Let's do that now. In index.js, we're going to scroll down and right beneath our player instantiation, I'm going to create a doors array like so. This is going to store all of the doors associated with one of our levels because we might have multiple, but in this case we're only going to have one. So inside of this I'll put a new sprite with a capital S. And what does a new sprite take? Well, it definitely takes a position. Where do we want this door placed? Well, I want it placed at an X position of 0 and Y position of 0 just to start. And then we need to reference the door image. So image, src, image source is going to be equal to what? I'm going to go inside of my image folder and then find door open with a capital O .png. That should be good enough to create a door sprite, but we want to render the sprite out, which means we need to go into our animation loop and kind of follow the same pattern we're doing right here for our collision blocks. So I'm going to copy those 3 lines, paste them down below, and then instead of looping through our collision blocks, I'm going to loop through our new doors array, and then for each door within this array, I want to call the door.draw function that comes from our sprite class. So if we save this, go to our game and refresh, we're going to see our doors rendered out in the top left-hand corner. But this is an animation, so we want to make sure that this is animating. And we can do that simply by going up to our door instantiation here, and then adding in a property called frame rate. We already set this up. How many frames does our door have? It has 1, 2, 3, 4, 5. So we just say 5 right here. We can save, refresh, and now we have a door animation. Now this is kind of fast for my liking, so I want to add in a frame buffer property to slow our animation down. And I'm going to put a frame buffer about 5 right here to start, see what that looks like. I save and refresh, and that is actually exactly the same. So we have an issue right here where frame buffer is not affecting our actual sprite animation. Let's go inside of our sprite class, and if we look up above, we're not actually passing through a frame buffer property. So we want to make sure that we're passing that through. Frame buffer is by default going to be equal to what? Well, 2, because that's what we're assigning down here. So let's say our default will be equal to 2, but for our door, it's going to be equal to 5 as we're passing it through, which means for actual this.frameBuffer property, we're going to assign that equal to the frame buffer argument we're passing through. So let's save that, refresh, and that is definitely slowed down, so looking great. Now I don't want to keep looping this animation. I only want this to happen once. It doesn't make sense for this to be opening and closing unless it's like a ghost door or something like that. So if I want to prevent this from looping, I'm going to go to index.js, and within our new sprite right here for our door, I'm going to declare our loop should be equal to false. We should not be looping through this. But kind of the same deal as what we had for frame buffer. We can save this, refresh, and we're still looping through our door. Just means we need to add some loop property changes over to sprite.js. So when we're creating our original sprite, we're not actually passing through anything that says should we loop or not. So I'm going to add in a loop argument right here within our constructor. And then down below, I need to make sure that for our default sprite, that we're declaring this dot loop is equal to the loop we're passing through as this argument we just added in. So now loop will either be true or false based on what we pass through when we create a sprite, but down below, within update frames, we need to determine how our looping should be affected based off this new loop property. So we know right here with this else statement, we are resetting our frame back to 0, which means we go back to the beginning of the animation. What we can do is change this to an else if and say if this dot loop is equal to true, then we want to go back to the beginning. So if this dot loop is equal to false, we're never going to reset that frame, and we're never going to be able to keep adding on a frame to the current position. We're just going to stop the animation altogether if this dot loop is equal to false. So let's save this, refresh, and now you can see that animation definitely only happened once for our door. Now the issue is our player is no longer looping, so we need to fix this to take into account our new changes. So the first thing I do is go over to index.js and look at our player instantiation right here. We're not declaring whether or not we want this to loop, so I think it makes sense in this case to give a default of loop equal to true for each of our sprites. So I'll go up and declare loop should be equal to true by default. Let's see if that fixes things. Refresh, and now we are definitely looping through everything, which is great. All we had to do was add in that default. So now we need to detect for collision between our player and the door, but the door is up there. We can't even reach it because of our collision blocks. We need to change our door's position to be somewhere over here on the right-hand side of our level. Now we could go ahead and just guess things and place it in the right position within our code, but that's a little slow for my liking. So what we can do is head on over to Tiled, the map editor, and select our miscellaneous objects layer right here. With this selected, we can open on up our object tile set and select our door. And now with the door selected, we can hit this little image stamp tool, and then we can draw a door wherever we want on our map. So if I want this door drawn right here within our miscellaneous layer, I can click, and now our door is drawn. And it doesn't really help that much to just kind of click this there, but what we do want is to grab the X and Y coordinates associated with this door. So our X coordinate is going to be 767. Let's go back to our code, find where we are creating our door. It's going to be right here on line 50 for me. And then I want to change our X position equal to 767. Hit save and refresh, and you can see that's almost in the perfect position for our X coordinate. Now what is our Y coordinate? It says 381. But one issue here is the Y coordinate is the bottom of the image we're currently referencing. So I use this select tool right here to drag our image upwards, and I drag it to the very top on the Y axis. You're going to see that we still have a Y coordinate of 112 because that is the bottom of this image, when in reality our canvas draws from the top down. So what we want to do is get the Y coordinate but subtract from this Y coordinate the height of this actual object, which is also listed right here. So about 381, 382 minus 112, that is going to be 270 pixels. So we'll head back to our code and say we want this door placed 270 pixels from the top of our map. So refresh, and now that is within the perfect position. Great. Now one thing you might have noticed is this door just opens by default. We only want to open this door if we activate some event. So we don't want to run this animation as soon as we create the door, and therefore we want to add in an autoplay property. So within our door, I'm going to declare that our autoplay should be equal to false by default, specifically for our door. And once we add this property in, we need to go on over to our sprite class and begin integrating it here. So autoplay, by default, I'm going to set equal to true because I do want most of my stuff to autoplay, and I'm only setting autoplay equal to false for our door instantiation anyways, so I think this is okay. We're going to create a property down below called this .autoplay, set it equal to the argument we're passing through, and this is how we're going to use this. We're going to go on down to update frames, and we're going to say if this .autoplay is set equal to false, meaning we do not want this to start right off the bat. We're just going to return all together, and we're not going to play anything else. If we save this, refresh, you can see that our door is closed, but our player is still going because we never actually said that our autoplay property for our player should be equal to false. Now going back here, I want to make sure that we have the ability to play our door animation when we're ready. So preemptively, I'm going to add in a method called play, and whenever we call play on a sprite, I'm going to set this .autoplay equal to true. That means that this is no longer going to run, and we can run through our actual frame animation. So let's give this a save and refresh, make sure everything is still working. Now what we want to do is have our player walk over here, and we're going to detect for a collision between our player and our door. If the two are indeed colliding, we're going to activate that play animation, and we're going to switch our player sprite to an animation where they actually go through the door. So let's start by detecting for collision. How would we go about that? Well, I know I want to activate this code within event-listeners.js, specifically when I press W on my keyboard, because that is where I'm supposed to jump up. I want this to kind of double as going through doors. So what I want to do is grab the door whenever I press W so I can start detecting for a collision. And to grab the door, I need to loop through our doors array because we might have multiple. We want to detect which door are we currently looping through. So to loop through our doors, I'm going to use a traditional for loop and say for let I equal to 0. And then for our next statement, I'll say as long as I is less than doors.length, I want to increase I for every iteration of this for loop. And I want to select the door we're currently on with const door is equal to doors I. And now that I have this door available to us, I can run an if statement that compares the location between our player and the current door we're selecting right here. Now, that's going to be quite lengthy to write out, and we have actually already done this over within player.js. So if we look, when we're checking for either horizontal or vertical collisions, we'll start with this right here, we have collision detection code. It's all within this if statement. So to save some time, we can simply copy this, go back to event-listeners.js, and paste it within our new if statement, and just make sure that we're adding some opening and closing curly brackets. So the code for this is pretty much going to be exactly the same. We want to select our player's hitbox, which we're already referencing right here, but we can't reference this because this is more class syntax. We need to reference the actual player object in which we created. That's going to give us the hitbox details. And then we don't want to reference a collision block, but rather the current door we're looping through. So we're going to change collision block in these 6 locations with door instead. And with just this, we're monitoring for a collision between our player and our door. And to prove this to you, we can console log out. We are colliding whenever we press W and we're intersecting with the door. So let's refresh and then open up our console so we can actually see that log. And I'll move that to the bottom so we can see it better. We move on over to the right. And now when I press W on my keyboard, we're definitely colliding with that door. But once I go off of it, we are no longer logging out that text. Now one thing we want to do is make sure that if we are colliding, that we don't actually jump up. So right here, if we are colliding, we're just going to return all together, which just means we don't call any of the following code within our actual switch case. So save, refresh, go over to the right. And now when we press W, we're no longer jumping, but we can still jump as long as we're not colliding with the door. Now before we go to a switch sprite animation, you're going to notice that we're saying that we are colliding when it looks like we're kind of off with the door. So we want to change our collision detection code just a little bit to make sure that we only activate this collision if we're in the middle of the door rather than just touching it. So here's how this is going to work. We're going to have the boundaries for our main door right here, and then of course we're going to have the boundaries for our player. We need to monitor for whether or not the left side of our player right here is greater than or equal to the left side of our bound box. We need to do the same thing for the right side. Is the right side of our player over here less than or equal to the right side of our bounding box? It's just a small little change up to our equation to make sure that we're colliding fully on the inside rather than just touching this box a little bit from the outside. So to write that, we'll start with the right side of our player, which we can get by adding on to our position.x, our player.width. That'll give us the right side of the player. So now we're saying if the right side of our player, right here, is less than or equal to the right side of our door, then we are indeed colliding. That's exactly what we want. Let's do the left side of our player. So we have the left side of our player with position.x. We no longer need to track our player hitbox.width. We just want that full left side of the player. We're saying if the left side of the player is greater than the left side of our door, we are colliding. But looking at this real quick, we always want to make sure that we're referencing the correct thing. We don't want our player width, but rather our player hitbox.width because our hitbox is much smaller, and that's actually where our player is moving around on the map. So let's save that, refresh, and see if things work. So if I go over to the right and start jumping, looks like we're good to go. We're not fully in the middle of our door. Same thing with the right side, but if I go near the middle and hit W, we're saying we are colliding because we're in the middle. That is perfect. That is exactly what we want, and we can move on to the next step. So what do I want to do next? Well, when we collide here, we don't need a console log anymore, but rather what I want to do is select our player and add on a prevent input property, and I'm going to set this equal to true. So as long as we're colliding with this door, I no longer want the player to be able to move around. So at the very top of our event listener, I can say if our player.prevent input is equal to true, meaning we cannot move, we're going to return and we cannot call any of the following code down below. That's simple enough, but now I also want to make sure that I set our player velocity.x equal to 0, so we're not sliding around or anything like that. I'll do the same thing for y, just in case. Player velocity.y is equal to 0, and then we prevent movement altogether. And now we want to switch on over to a different sprite. So we're going to call switch sprite, and what sprite do we want to switch on over to? Well, we have an enter door sprite right here. We look at that, it's 1, 2, 3, 4, 5, 6, 7, 8 frames long. So we're going to switch on over to enter door, and now we need to make sure that this sprite is imported within index.js. So right now we only have these 4 animations. I'm going to add in one more by copying run left, and I'm going to replace run left with enter door. Our frame rate's going to be the same. Our frame buffer, let's just go ahead and keep it at 4 for now. That seems totally fine. But our image source is going to be enter door.png instead of run left. And we don't want to loop this. We actually want to set this equal to false because it doesn't really make sense to enter a door, kind of teleport backwards, and then try entering the door again. Now if we save this, refresh, you might think that entering the door will switch on over to the sprite completely. And I'm pressing W right now, so we should be switching over to that sprite, but we're not. Why is that? Well, we need to look within our animation loop to find out. Although we are switching over to that sprite, by default, we're always switching back to either idle left or idle right. So basically what we wanted to do is say, if we're preventing our player input, we do not want to call any of this code. It would kind of be like adding in an if statement that says if our player.prevent input is equal to true, then we're going to return all together. But in this case, we wouldn't be calling player.draw or player.update, which we definitely still need to actually render a player out and animate them on our level. So instead of calling return right here directly within animate, what I'm going to do is cut all this code out from line 93 down to 106, hit Command X to cut that out, and I'm going to put this within its own method within player.js. So right beneath update, I'll call handle input, and then paste in all that code, and if I'm pasting this in here, I don't want to reference a player object, I just want to reference this, which is going to be basically the same thing since we're calling this from the player class. So now if I call return, I'm only returning from this function. I'm not going to cause any other code to be skipped over within our animation loop. But in order to make sure that handle input is being called, well, we need to either call this within our player's update function up above, or you can just call it within index.js. So right before I call draw, I'm going to call player.handle input, and that's going to match up with what we have over here. And if I really want to be pretty good with my code quality, I can pass through our keys as an argument, save, and then make sure that I'm passing through our keys value over here within handle input. And now we know exactly where this keys object is coming from. It's coming through an argument, which we're calling right here and assigning up above. So let's save this, refresh, start walking around, and now when we hit W in front of our door, we're going to activate that new animation. So you can see right now our player is looping through this animation, even though I believe we have loop set equal to false for it. So let's look up above for enter door, and yes, loop is equal to false, so something is going on here. Let's check player.js and go up to our constructor. We can see within our arguments we're not actually passing through a loop property, which is coming through our player class, and that should go up to our sprite class. So we're going to pass through a loop here, and then within super, we're also going to pass through a loop. Now this is good for determining whether or not our initial animation should be looping or not. But the thing is, when we switch to another animation, we're not actually setting our loop property equal to the new value of this new animation's loop. So in order to do that, we need to make sure within switch sprite, we're saying that this .loop associated with our player is equal to the loop value of the current animation we want to switch to. So I'm going to copy this line, get the current animation, which is this right here, and then instead of referencing frame buffer, I'm going to say get the new loop property. With that, we should not loop whenever we press W in front of our door. Hit W, and yeah, we only call that once. That's exactly what we want. What else is left really? Well, we need to open our door, and we already set ourselves up for success with this by adding in that play property specifically for sprite.js, right here where we set autoplay equal to true. So all we have to do is call door.play whenever we hit W, and we can do that within event listeners.js. So after we switch our sprite, we're also going to call door.play to actually play that animation. We should be good to go. Let's refresh after a save, and then in front of our door, hit W. That opens, and now everything is in the exact position we need it to be to begin changing to a different level. So with this, we can head back on over to do and check off entering doors. So now finally, as soon as we enter a door, we want to go on to the next level to present a new challenge to our player. So how would we go about doing that? Well, essentially what I want to do is when we walk inside of here, I want to run some sort of onComplete function that fades our screen to black. So whenever this animation where we walk through the door completes, we're going to fade in a black screen, activate the code that brings up a completely new level, and then spawn our player in a new position to begin the new level. So first thing first though, let's add in an onComplete property for when we complete this animation and then fade our screen to black. So to add in an onComplete property, I'm going to go to index.js, and I want to focus on our player animations. We know the animation when we enter a door is going to be right here, so I'm going to add in a property called onComplete, and this is going to be equal to a function. So whenever this animation completes, we want to console log out completed animation. But now we need to integrate the functionality in which we can actually call onComplete once this animation ends. So here is a way to do it. We can go over to sprite.js, and within our constructor, we can add in a property called this.current animation, and this is going to be equal to undefined to start. We're not actually going to assign anything to it within our sprite class, but over in player.js, when we're calling switch sprite, the first thing I want to do is assign this new property, which we now have access to because player inherits from sprite. This.current animation is going to be equal to the animation we just switched to. So in this case, we can get the animation with this.animation's name. And now that's going to be stored within this.current animation. Great. Now that we have access to this property over in sprite.js, what we can do is call this.current animation.onComplete. But we only want to call this under certain conditions, such as does this onComplete property actually exist on the current animation? And other conditions such as have we reached the end of our animation? We need to make sure that we're checking for those conditions, and we can do that within update frames. So at the very bottom, the first thing I want to check for is if we have this.current animation set. So we're checking for that, but if we also want to check if this has an onComplete property, we can use the optional syntax with a question mark, which first says, does this.current animation exist? If it does, continue on with the dot and check if onComplete exists. So it's basically a shorthand way of writing a double conditional with and, but we're just doing it a lot cleaner using this syntax. So if our current animation exists and it has an onComplete property, what do we want to do? We'll call this .current animation, not frame, .onComplete and activate that function. But even if it exists, we only want to call this at a certain time, specifically when we are at the end of our animation. So how do we check whether or not we're at the end of one of these animations? Well, we can use an if statement that says if this.current frame is equal to the end frame of our animation, which we can get with this.frame rate minus 1, then we're going to call onComplete. But another issue is we might be at the very end of our animation, and since we're at the end, we're just going to call the statement right here repeatedly. We only want to ever call this once, so we just need to add on an extra conditional with an and statement that says if this.current animation is active. And we actually want to add a bang operator to this. So if the current animation has not been activated, then that is when we want to call .onComplete. And to make sure this doesn't run again, we need to set this current animation is active equal to true as soon as we activate the animation. So this is what things should look like. And when we save and refresh and open up our console, now when we enter the door, we should see some text being logged out. We're activating that onComplete function. So we enter, and there is our completed animation text as soon as we reach the very last frame right here. Perfect, that is exactly what we want. So now we can call at the end of our animation some code which fades in a black background. So how would we get started with that? Well, we need to create a black background first, and the best place to do this is going to be within our animation loop in index.js. So after everything has been called, I also want to create a black rectangle, which I can do with c.fill rect, and I want this to cover the whole canvas. So I can do that with 0, 0, canvas width, and then also canvas height. And right before this, I'm going to assign our c.fill style equal to black. And with just this, we shouldn't see anything at all. That's where we want to start. Save and refresh, and yes, our whole game is gone because it's being covered by this black rectangle. That's totally okay though. So what we're going to do is fade this out. And to fade this out with canvas, we need to do something called c.save, and then after this call c.global alpha. Let's set this equal to a value such as 0 or 1. Anywhere from 0 to 1. This is basically going to determine the transparency of this rectangle right here. Now at the end of c.fillRect, I'm going to call c.restore. And basically what save and restore do is it says only apply this global alpha to whatever code is inside of save and restore. So right now I'm saying only make this transparency 0 for these two lines right here. I don't want our player to be invisible. I don't want our doors to be invisible. Only what is within save and restore. So let's save and refresh, and now we see everything. And you can see if I change this equal to like 0.5 or something like that, we have a nice black transparent background. We're going to basically fade this alpha value in and then fade it out. So if we want to fade this in and out, we need to make sure that this is dynamic. And I'm going to assign this equal to overlay.opacity. But in order to make sure that I can actually assign it to this, I need to create that object. So up above, we'll declare that our const of overlay is equal to an object with an opacity property. And this by default is going to be equal to 0, of course, because we don't want to see it. As long as we have that, we should not see that black background. Perfect. But what we're going to do is when we complete our enter door animation, yes, we're going to console like this out, but we want to fade in that new value we just created. So what is that value? It's going to be overlay.opacity. How do we get this from 0 over to 1? Well, I think the easiest way to do it is going to be using an animation library. And there's one that we can pull in really easily. It is called GSAP. I pretty much use it for every game that I do. So let's just do a quick search for GSAP CDN. Go to the very first result at cdnjs.com. And we're going to be grabbing version 3.11.1. We can just grab the very first result, click copy script tag, go over to index.html, and at the very top of our script tags, paste that on in. And now we have access to the GSAP library, which we can do to animate things, such as that opacity value. So let's do exactly that. In index.js, if I want to change overlay.opacity from 0 to 1, I'm going to call gsap.to. This basically says go from this value to the next one. Now what object do we want to change a property of? Simply our overlay object. Now I'll add in a comma, and add an object right here, and declare what property I want to change. I want to animate our opacity property to the value 1. And this is all we need to fade in this value right here. So let's save, go back to our game, refresh, and try entering our door. And on complete, we should see that faded in black background. So I go in, and yes, we are on the right path. So now that we have this black background, what do we want to happen? Well, essentially, we want to reinitialize all of our values associated with our game, but we're going to assign new things such as new collision blocks, a new background, and so forth. So right now we're assigning all these on load. We're going to want to assign them when we call a function instead. So it's time to start setting up our separate levels. Right beneath where we're assigning canvas height, I'll create a let called level. Set it equal to 1 because that's going to be the first level we start on. And then beneath this, I'll create a levels let. And this is going to be equal to an object that contains all the data related to our levels. So level 1 will be equal to an object, and inside of this I'm going to have an init property set equal to a function. So when I select levels 1 init, we're going to call all the code that we need to populate level 1 with the level 1 data. So what is the level 1 data? Well, pretty much everything that we already have written out here. So what I want to do is move some of these right above where we're declaring level and levels. And I'm going to change our const to let. So let parse collisions, let collision blocks, and let level background 1. I want all of these to be lets because I want to assign them within this init function instead of assigning them directly when we load our file. So I'm also going to copy these from here and put them within init. But when they're within init, we can get rid of the lets because they're already declared up above. We can also get rid of the declarations right here because we're going to assign these only when we call init for these levels. So these are more like global objects in which we're assigning whenever we call init. And we want to do this for basically every object we know is going to change. So we know our collision blocks are going to change, which is great. We're putting that within init. We know our background is going to change, but we really shouldn't be calling this background level 1 anymore. This is more going to be a generic background instead. So I'm going to rename background level 1 to background in any location in which it exists. Do a quick search for background level 1. Change it right here as well. And we can leave this image right here because in this case we do want to assign background level 1 to whatever background we're rendering out. But let's scroll on down. What else is going to change on a level by level basis? It looks like our doors will for sure change. So let's grab this, go to the top, paste this in, change const to let. And now doors will be assigned whenever we call init for level 1. So inside of init, I'll say doors is equal to that array in which I cut out. And now this door will only be available when we call level 1 init. Is there anything else we need to change on a level by level basis? I'm scrolling down and no, it doesn't really look like it. We might change some stuff with our player though. So let's move player up to the top right beneath doors. I think we can keep this as a const and we might just change some properties on the fly. Now the first thing I want to do is actually call init on level 1 right here because all this init code is being called whenever the file was loaded. Instead at the very bottom, yes, we're going to call animate, but before that, I'm going to select our levels object, get the current level we're on, which we're starting off on level 1, and then call its init function. And everything should still work the same as long as we've done this right. So let's save and refresh, and it looks like we're definitely having an issue there with our player falling off the collision blocks. So if we scroll on up to our code where we're actually assigning our collision blocks, it's going to be within init, But if you can recall from a previous lesson, right here, we're trying to reference collision blocks, but it's just not assigned when we're actually instantiating a player. So we don't want to add in collision blocks right here when we're instantiating a player. Instead, we're going to assign that dynamically whenever we call init for a level. So we'll grab our player object and then assign collision blocks equal to the collision blocks in which we're parsing out up above. As long as we save that and refresh, now our collisions work again. We should be able to go through this door and get the same result, but with cleaner code. So we know we're going to fade in that overlay, but when this animation completes, we want to increase our level. So GSAP provides its own onComplete property, and this will be equal to an arrow function. And now within this, we can say we want to increase level by 1. That's going to push us to level 2. And then we want to call level 2's init function. So we'll grab levels, get the current level we're on, which in this case would be 2 initially, and then call init on top of that. And that should send us on over to level 2, as long as level 2 exists, which currently it does not. So if we want to go to level 2, I'll grab everything within 1, paste it down below, change this 1 to 2, and now whatever we call within init is going to activate for our second level. So we're going to keep our collisions the same just to start. The only thing I want to change right now is going to be the background image in which we're using. So rather than assigning background equal to background level 1, we're going to change this to 2, because we have that available to us right here. This is what it's going to look like. So as long as we reassign our background, we should see it when we fade our overlay back out to an opacity of 0. So let's go back to that GSAP code, and on complete, we're going to init our new level, and then we can call gsap.to, grab our overlay, and then fade its opacity out back to 0. So let's see what this looks like. Let's save, refresh, and go inside our door. We're going to fade out to black, and now we can see our new level. We see all the collision blocks from level 1. We're going to change that really quickly, but we did change our background image. That is a great start. Now, if we look at things, our player is still in the same position in which they were, and we're still rendering out our door. So we want to make sure that we change our player to a position somewhere up here, and we want to get rid of this door completely whenever we activate level 2. So let's see what level 2 looks like. We have this door, but we want to put this door in a new position relative to our level 2 map. So how do we go about doing that? Well, we want to go over to tiled and do the same thing we did before with placing our door. We can select an object layer, which is indicated by these purple boxes, click the stamp tool, and then place our door wherever we'd like. And I know I want to place it down here, so I'll click and get the coordinates for this new door. So the X is going to be 782. Let's go back on over to our code and assign this X coordinate equal to that. And then we just need our Y, which remember is going to be the Y minus the height of the door. So 448 about minus 112 is going to be 446. 336, I believe, if my math on the fly is correct. So I think I said 336. Refresh, and yeah, we're still at level 1. It's kind of annoying having to walk over there to see where everything is placed. So if you just want to start out at level 2, all you need to do is scroll on up to where you're actually assigning levels, and here it is on line 61 for me. I'm going to assign our current level equal to 2, save and refresh, and now that looks a lot better. So I actually got that right on the y-axis. That is great. And now our door is over here, but it kind of looks like we have 2 doors, and I think that's just because when I exported background level 2, I included the door. So all we really need to do in this case is make sure that our new door, in which we actually want to interact with, is overlaid directly on top of the background door. Or we could just export the whole background image without the background door. But let's just do the quick way. Let's move our door over to the left a little bit. I'm going to say this should be around 760, 776. A little closer, let's subtract around 4 more pixels, 772. And that seems to be about perfect. I like how that looks. Now when we activate level 2, our player should be somewhere up here. So something we can do is head on over to tiled, grab a small object like this, and place it in the position we want to spawn our player. I'll click right here, and then grab the coordinates associated with this. So it is 96 for X, and let's just say this is going to be around 140 for Y. So 96 and 140. Let's change our player's position on those 2 coordinates. So player position.x is going to be equal to 96, and then player.position.y will be equal to 140. We save this, refresh, and now our player is spawned around that position. This is good enough for me, and you can kind of fine tune things as you like, but this is a totally good start. So obviously we have the issue where our player is on top of these collision blocks. We want completely new collision blocks for our new map. How do we actually get those? Well, we need to do the same thing that we did for level 1. We need to export this whole file and then grab the data associated with our collisions. So I'll go to File, and then Export As, and then I can save this wherever I like. I pretty much save this as a temporary file within Downloads, and I'll call this level 2. and go back to my Finder. So this is going to be within downloads, and right here, level2.js, I want to open that, and then I can scroll down until I find our collisions, or I can do Command F and search for collisions instead, and this is all of our collision data. So I want to copy this array and go back to our code, and I'm going to go inside of our data folder where we assigned our original collisions level 1 equal to the collisions array which we exported from level 1. And in this case, I'm going to create a new const called collisions level 2, and assign to this the new array in which I just copied. So these are all the collisions related to level 2. And now that we have this available to us, when we activate level 2 within index.js, we can make sure that we're referencing collisions level 2, parsing them to a 2D array, and then creating objects from that 2D array and populating collision blocks from all that data that we just parsed. So let's see how this works. Let's save, refresh, and all those collision blocks are immediately in the correct spot. And now our player reacts accordingly, which is really freaking cool. So if we go ahead and press W on this door, yes, we're going to enter, but we don't currently have another level to go to. We want to go on to level 3. And level 3 is available to us within Finder right here. So I want you to open this up, export your collision blocks, and then try to get level 3 up and running on your own. So pause the video and see if you can do it. Otherwise, let's get right on into it. I'm going to open up level 3, click on that, and that should be open and tiled for me, which it is. And you'll see I have my collisions up here. So the first thing I'm going to do is actually export these collisions. I'll go to File, Export As, and then save this as level 3. That's totally fine within Downloads. That saves, and now I can go over to my Finder once more, click Downloads, open up level3.js. Here it is. I'll do a Command F for collisions, and this is all the data I want associated with our level 3 collisions. So I'm going to copy this array, go back to our code, go within collisions.js, create a new const called collisions level 3, set it equal to the array I just copied. And now, within index.js, I want to state what happens as soon as we go to level 3. So let's create level 3. I'm going to copy level 2, paste it down below, and change the 2 to a 3. And now I don't want to select collisions from level 2, I want to select collisions from level 3. So to test that this is working, I'm going to find my levellet, change level to 3 by default. So after changing that, save and refresh, and you're going to notice no collision blocks are being spawned. So why might this occur? And you might have even come across this trying to do it yourself. Well, in order to figure this out, we need to look at our data for level 3. So we're going to go inside of collisions.js, and if we look at this, well, oh, that is new. We are using a different symbol right here for collisions level 3 than we are using for 2 and 1. And if that's the case, we need to tell our parser how to react when we hit a symbol of 250 rather than 292. So all of our parsing code was within utils.js, and whenever we hit a symbol of 292, we're creating a new collision block. We also want to do this if our symbol is equal to now, I believe it was 250, exactly 250. So as long as our symbol is equal to 250, we'll push in collision blocks, and this should work for this level as well. So after a save and refresh, now we have those collision blocks in place. That is solved. We need to change the location of our door though, so we'll do that next. In level 3, I wanted to change the position of our door sprite over to where it was on the left, and I am lazy, so I'm just going to do this directly within tiled. Select our layer right here, grab the door, and make sure that our little image stamp is selected, and just place this directly on top of where it is on the map. I click, and I have those coordinates available to me. So X is going to be about 175, and then Y is going to be the same as it was for level 2. So I'll change X to 175, save and refresh, and now that's pretty much in the same location, just a little bit off, so we'll just subtract a pixel or add on a pixel to X, and subtract 1 from Y, and that seems to be pretty good. Now it doesn't really make sense if our player starts all the way over here. Let's start our player in the top right, and I'll do the same thing that we did with the box. Just click in a location in which I want our player to spawn, and that's going to be 817 by around 180-ish. So let's add that in. We're going to change our player position on the x-axis to 817. We'll leave this as 140 for now, and our player is too high up. I want this to be a Y of about 180. Let's push our player down a bit by changing 140 to 180. And it looks like we're just spawning on top of the collision blocks, so we probably need to subtract from our player position on the x-axis. Let's save, refresh, and it looks like we just need to keep doing this until we get it right. I'm going to subtract about 50 pixels from X, and I'll add on around 50 for Y. Save and refresh, and now we're in a good spot when we spawn. Perfect. So that puts level 3 in really good shape, but now I just need to make sure that our transitions between doors work. So let's go back to level 1. I'm going to find our levellet, change this back to 1 instead of 3. It'll start us off here. We go inside of our door, we should call onComplete, activate level 2, and yeah, we definitely have an issue up here where we can no longer see our player. We need to switch our sprite back to the idle right position, and we also need to make sure that prevent default is turned off. So let's do that whenever onComplete is basically midway, meaning that our black overlay has faded in. We've changed our level and the new level has been initialized. We can call player.switch sprite, and then what do I want to switch to? Well, idle right. That should have us facing to the right as soon as we go through one of these doors. So let's try it out. We go through. Now we're facing towards the right, but I can't move because prevent input is still set to true. After we call player.switch sprite, I also want to call player.prevent input and set this equal to false. And that way we can move around again and navigate our level. So we go inside of the door after that. We're animated and now we can move around in level 2. We have all of our collision blocks in place. So let's try going to level 3, see how that looks. We try going inside and you might have noticed, well, we are not going fully in the door and proceeding to the next level. So why is that? Well, let's investigate. We need to go on over to sprite.js and look within update frames. So right now we're only able to call onComplete if isActive is equal to false. And this is what's making sure onComplete is only ever called once. We call it once, we set isActive equal to true, we can no longer call this code. So what we need to do is make sure that we're setting this back equal to false whenever we load a new level, and that will allow us to call this again once we enter a new door. So over in index.js, let's find level 2, and what I want to say is if our player.currentAnimation exists, then I want to call our player.currentAnimation and set isActive back equal to false. And that should make sure we can call onComplete again when ready. We want to make sure that we're putting this on a init for each level, so I'll put it within level 3 as well, and also level 1. So let's save with this. Fresh, looking good, we go through the door. onComplete is called, everything's still activated. And now when we go through this, because we set our current animation is active equal to false, we should be able to call onComplete again, which indeed we are, so looking great. If I try going through our final door, you're going to notice that we just fade to black, and if I open up my console, there should be a bug within there. And indeed, there is. So we're trying to call a init on a level that does not exist, so what you can do is either add level 4, or you can just loop back to the very beginning. I'm just going to loop back to the very beginning for the time being, so I'll say if level is equal to 4, which does not currently exist, then I'm going to set the level back equal to level 1. And that just makes sure that I init on level 1 once I hit to level 3. And I can test this real quick by changing level 1 to 3 to start. That'll start us off over here. And now when I go inside the door, I should go back to level 1. And indeed I do. And now the loop is complete. We can go between all these rooms with all the different collision blocks and so forth. And it's just going to allow us to keep doing this until we add in levels, or start adding in multiple doors and new features. But this is the general gist of how you're going to create a multi-level platformer. I really suggest creating multiple doors, multiple locations in which you can go, and really start experimenting with things. Once you start adding some enemies in here and a little bit of functionality, it's going to create a really, really cool game. So the last thing I do here is just comment out our collision blocks so we can see the full thing and really enjoy our creation. To comment these out, I'll scroll down to our animation loop, and I know I'm rendering out our collision blocks right here. Comment that out, refresh, and now we have this full map in which we can traverse. So with this functionality in place, we can head back to To-Do and check off Change Levels. Now you might not want your platform to be restricted to just the confines of one screen, and if that's the case, well, I recommend checking out this video right here. We're just going to show you how to extend your level through the creation of a Mario-based side-scroller game.